Mm. Well, Tekar.
Assalamualaikum and good morning, ladies and gentlemen. The event will start in 1 minute. Please register your attendance using the given link in the chat box. Thank you. Assalamualaikum and good morning. Yang berbahagia, Dr. Nurhaiza Ahmad, Director of iADORE2020, speakers, lecturers and participants. Welcome to the International Symposium on Advanced Data Analysis and Operational Research 2020 iADORE 2020. I am Nurihan binti Yaakob, your moderator for today. This symposium focuses on research discourse relating to areas of statistics and operational research. iADORE 2020 is an excellent platform for statisticians, operational research analysts, and industry practitioners to get the latest insight on various applications in the area. This event is scheduled from December 7 to December 8, 2020 virtually. iADORE 2020 is a collaborative effort between the main organizer, Universiti Teknologi Malaysia, together with the University of Dhaka, Bangladesh, and Universitas Andalas, Indonesia. Today, we are very lucky to have a session with many knowledgeable speakers. I hope all participants will acquire all the knowledge from the speakers. All participants are welcome to raise questions in the chat box. Without further delay, I would like to invite the Director of iADORE 2020, Dr. Nurhaiza Ahmad, for a welcoming speech. So, Dr., the floor is yours. Thank you, Dr.
Okay. Assalamualaikum and good morning, everyone. My name is Nurhaiza. Let's start with starting the event with the Surah Al-Fatihah so that Allah will bless this event onwards. I'd like to welcome everyone to this event. This is a two-day event. The first event will be hosted by the University of Teknologi Malaysia, and the next and tomorrow will be hosted by University of Dhaka. We have several talks lined up for you, and we hope that everyone will get the benefit of this majlis ilmu, or the knowledge transfer. And the talks will be given by experts from UTM, University of Dhaka, and UNAND University as well. We'll also have 2 showcase events in which participants can learn new skills. For example, in the first day, we'll have a showcase event dealing with a software called Simulate that focus on optimization, and the second day event on showcase skills will be brought to you by a speaker from Dhaka University, and it will talk about an application in our software, which is our Shiny. My most warmest welcome to everyone, and we hope that you will have that you will enjoy this meeting. This is going to be a long symposium, but we will have breaks in between, and please do have your breaks so that you will not be cooped up in this symposium. But anyway, enjoy the event. Thank you very much. Thank you, Dr. Nurihan. I'm passing over to you.
Alright, thank you so much to Dr. Nurihan. Allow me to remind you once again, participants, please register your attendance through the link given in the chat box. All are welcome to raise your question in the chat box. Your questions will be answered during the Q&A session. Without further ado, I will pass to the moderator of the first keynote speaker, Dr. Farhana Johar. Thank you. So, Dr. Farhana.
All right. Okay, thank you, host. All right. First of all, I would like to introduce myself. Okay, my name is Farhana Johar. So I'm from the research group of mathematical optimizations, RGMO, and I will be the moderator of our first keynote speaker for session today. All right, so on behalf of the organizers, I would like also to extend my warm welcome to all the guests to the International Symposiums on Advanced Data Analysis and Operational Research, iADORE 2020. So before we proceed, let's introduce our first keynote speaker. So Dr. Zaitul Marlizawati Zainuddin is an associate professor at Department of Mathematical Sciences, Faculty of Science, Universiti Teknologi Malaysia, with a PhD in mathematics and statistics and more than 10 years of experience as a lecturer and researcher in operational research, optimizations, and also the heuristic method. She is able to tailor her skills to address the needs of various industries. She is a member of Management Science, Operation Research Society of Malaysia, and the OR Society, an international learned society in the field of operational research. She was the head of operational research panel at the Department of Mathematical Sciences, and also was the leader of the research group on mathematical optimizations. And currently, she is Deputy Director of UTM Center for Industrial and Applied Mathematics. All right. So without further ado, may I invite Dr. Associate Professor Dr. Zaitul Marlizawati to deliver her speech. Dr. Zaitul, please.
Thank you, Dr. Farhana. Let me share my slide first, okay? Can you see the slide?
Yes.
All right, okay. All right, good. Assalamualaikum warahmatullahi wabarakatuh, and good morning to all present at the first session of iADORE 2020. Okay, thank you, the organizers for inviting me, okay, to iADORE 2020 as one of the keynote speakers, right? Actually, I love the acronym, okay, iADORE 2020, okay. So that's actually one of the reason why I accept the invitation, okay, because of the acronym. iADORE 2020. Okay, it's a nice positive word, okay, to end 2020 despite all the challenges that we have gone throughout the year. Okay, all right. So another reason is the theme of iADORE 2020. Okay, enriching transdisciplinary research collaborations beyond borders. Okay, I believe this theme is so close to the hearts of operational researchers. Okay, why? Because it is the nature of operational research. Okay. Okay. So as we know, the beginning of operational research has generally been attributed to the military services early in World War II, okay, where there was an urgent need to allocate scarce resources to the various military operations in an effective manner, right? Okay. So therefore, the British and then the US military management called upon a large number of scientists, okay, to deal with this problem and other strategic and tactical problems in military. Okay, so in effect, they were asked to do research on military operations. Okay, so these teams of scientists, okay, were the first OR teams who were also responsible in introducing the use of OR to a variety of organizations outside the military later. Okay, so regardless whether in military or in any organizations, as its name implies, operational or operations research involves research on operations, okay, which is clearly outlined by the principal phases for implementing OR in practice. So OR study, okay, the process starts with problem definition or problem formulation, which involves defining the problem under investigation, including gathering relevant information and data. Then the formulated problem is translated into mathematical relationships through model construction. Model solution involves the use of well-defined optimization algorithms in solving the model. Okay, so if the mathematical relationships are too complex to allow the determination of an analytic solution, then heuristic approach or simulation can be considered here, right? And then model validity checks whether or not the proposed model does what it is supposed to do. Okay, and then lastly, the implementation of the solution of a validated model involves the translation of the results into understandable operating instructions to be issued to the problem owner, right? Okay, so as mentioned earlier, after the World War II, OR were introduced to a variety of organizations such as manufacturing, transportation, construction, telecommunications, financial planning, healthcare, and also public services, to name a few. Okay, so another characteristic of OR, okay, is its broad viewpoint, okay, which means in solving a problem, OR adopts an organizational point of view, okay, which means the solution for the problem of a component of an organization, okay, must be consistent with the operation of the whole organization. All right, so an additional characteristic is that OR frequently attempts to find an optimal solution for the problem under consideration. And in finding this problem to cover all the many aspects of OR work would require a group of individuals having diverse backgrounds and skills. Okay, hence the transdisciplinary approach is necessary. Okay, so the team, the OR team typically needs to include individuals from mathematics, statistics, economics, business administration, computer science, engineering, the behavioral sciences, and of course, the individuals who are expert in special techniques of OR. Okay, so since the advent of the Industrial Revolution, okay, and even so now in the era of Fourth Industrial Revolution, the world has seen a remarkable growth and advances in technology. Therefore, it is expected that the era of Fourth Industrial Revolution to be marked by breakthroughs in emerging technologies in fields such as robotics, artificial intelligence, nanotechnology, quantum computing, biotechnology, the Internet of Things, okay, fully autonomous vehicles, to name a few. Okay, and what does this mean? Okay, so this will give rise to to data, okay, data availability, to faster computers. Therefore, better algorithms, okay, can be developed, okay, and lower fixed costs for optimization is expected, okay. And what does this bring to all of us? Okay, this brings opportunities. Okay, so let us promote data-driven decision making to unlock the value of available information and drive organizational improvement and operational efficiency. Okay, and since that is what we have been doing and will continue to do. Right. Okay, so OR is the science of better. Okay, so here I would like to take this opportunity, okay, to share with all of you, okay, a few projects of our OR group. Okay, so the first one is integrated line balancing and model sequencing problems for mixed model two-sided assembly line. Okay, so from this presentation, okay, you will see various applications of OR. So you will get the idea, to what are the areas, okay, of application of OR. Of course, this is not all, okay. This is not all. There are more to it. Okay? You will see. You will see more in the parallel sessions, okay, later, and also in the skill showcase, okay, during iADORE 2020. Right, I will not go into detail, okay, on the mathematical modeling part, okay, or the solution algorithm part, okay, as I mentioned just now, I'm just I will share. I'm just highlighting, okay, the area of application of OR, okay, to give you an idea on what OR is all about. Okay, so in integrated line balancing and model sequencing problems for mixed model two-sided assembly line. Okay, so within the limited length of work, okay, area, operators are placed and is responsible for each workstation to perform a non-overlapping task without interfering with one another. Okay, so this problem usually occur at a manufacturing plant. Okay, so line balancing problem is a problem of assigning various assembly tasks to the workstations. Okay, so in manufacturing a product, okay, there are many tasks involved. Okay, so in line balancing problem, the problem is of assigning these tasks, okay, to the workstations, right? And then in model sequencing problem, what we are dealing with is we need to determine a production sequence of models. Okay? For example, in the car manufacturing models, they have more than one car models to be assembled. Okay, and sometimes this model share the same task, right? So in model sequencing problem, we need to determine the production sequence of the available models, right? Right. Okay. So these are the mathematical formulation involved in the problem. As I said, I will not go into detail, okay, of this mathematical formulation. You can find the associate publication, okay, involves for this work, and you may find further information from there, right? Okay, so these are the mathematical formulations involved in mixed model, integrated line balancing and model sequencing problem for mixed model two-sided assembly line. Okay, so mixed model two-sided assembly line. Okay, here, and these are the objective, which is to minimize the utility work and idle time, the constraints involved. Okay, as you can see, it is a big problem, right? And this is the result representation. Okay, after we solve the model, in this case, in this work, the model is solved by using GAMS, okay, General Algebraic Modeling System. So this mixed integer linear programming model, okay, is solved exactly by using General Algebraic Modeling System, GAMS, right? And this is the results that you should expect, okay, from the from solving the model. Okay, as you can see here, okay, as you can see, we have model sequence, okay, where we have the model sequence A, B, and C, for example. So this is just a small example, okay, for you to see. Okay, we have A, B, and C. So A1, C1, A2, B1, the subscript represents the task. Okay, so task 1 for model A, task 1 for model C. So this is once we have solved the model, okay, this is the solution, okay, that we will get. This is how we should sequence, okay, the model. Okay, so model A first, then model C, then model A again, and the task, okay, that is assigned to the model. So model A task 1, model C task 1 first, then model A task 2, and so on, right? Okay, and this will give you the this diagram gives you the information on the idle time. Okay, the yellow part is the idle time and also the utility work that we have minimized just now, right? Okay, then next, okay, next. Another example, okay, is birth allocation problem and key crane scheduling. So this is a problem, of course, as you can see, okay, at a port, okay, and so this birth allocation problem and key crane scheduling fundamentally impact the effectiveness of port activities, okay, since birth and key cranes are the interface between the seaside, okay, the berth is the seaside part, and the key crane, okay, is the land side, okay, of the port, okay, in any port container terminal, right? So these two resources, okay, the berth and also the key crane, okay, should be simultaneously considered, okay, in making operational plans, because the physical limitation of berth space and the capacity limitation of key crane handling. So in this problem, okay, or in this project, what we did, okay, we integrate these two. We integrate these two problems, okay, the berth allocation problem and also the key crane scheduling problem in a model, okay. So well-planned berth and crane operations are important, okay, for fast terminal operations and compared to the costly investments into new equipment, right? So this is the mathematical model. Okay, mathematical model involves in solving the given problem. Okay, this is the operational framework. So as you can see, okay, we model the problem. Okay, the two problems, the berth allocation and also the key crane scheduling problems, are integrated, okay, in one model. Call it integrated model of berth allocation and key crane. Okay, then the algorithm, okay, the solution algorithm of genetic algorithm is used to solve this model. Okay, so here, these are the mathematical, the integrated model of the berth allocation and the key crane scheduling. Okay, and this is the genetic algorithm, okay, used, okay, to solve the given problem. So the genetic algorithm is a meta-heuristic methods. Okay, meta-heuristic methods usually used when we have a complex problem or ill-defined problem. Okay, so meta-heuristic method will give us near optimal solutions, and the tuning of the parameters, okay, is the important one of the important parts in meta-heuristic, okay, in order to find the global optimum of a problem, right? Okay, and this is the results. Okay, results representation of the problem just now. So figure 2 represents the berth, okay, allocation on the time-space diagram. Okay, and figure 3 shows the space-time diagram for the key crane. Okay, so this is how the berth is allocated for the arrival shapes, okay, and then how the key crane is scheduled, okay. Right. And another example, okay, another example that I will share with you today is on warehouse network redesign problem. Okay, So warehouse location model, okay, is one of the problem in location analysis, okay. But the difference is that this type of location problem strongly affected by the current economic situation, right? So in this problem, we will need to decide whether to add a new warehouse or to close any of the existing warehouse or to consolidate, okay, the available warehouses, okay, so that we will improve the cost or in what minimizing the cost, okay, in improving the cost. We need to decide on any of this, right? And we think that in deciding, okay, whether to add or to close or consolidate, zone-dependent fixed cost is also a crucial factors, okay, to be considered, okay, in the warehouse network redesign problem. So this is what we incorporate into the model. So this is what this is the diagram, okay, the illustration of what I've just mentioned just now, okay. So this is you can see the original network of warehouse, okay. Then after the redesigning the network, okay, after the consolidation or elimination process, now instead of 3 warehouse, now we have only 2, and therefore we need to reallocate the customers, okay, to the new network of warehouse here, right? And the objective that we use here is to minimize the transportation, operation, and also fixed cost of opening a new warehouse if need be, okay? And this is the simulated annealing, okay, algorithm that we use, okay, to solve the problem. Again, simulated annealing is another meta-heuristic algorithm, okay. So a few analysis on the parameters of simulated annealing were carried out, okay, during the project, right? So here, so this is the results representation of the problem. As you can see, yeah, the area under consideration is divided into zones, okay, and each zone has their own cost, okay. Means that if you want to open a warehouse, okay, at any particular zone, okay, so this cost will be incurred, okay, in the whole cost, okay, right? Okay, so as you can see here, we have for this particular problem, two warehouse should be open, okay, at zone 5 and at zone 9, okay, here to cover the demand for all the customers around the area, okay, right? Next, okay, next we will see the integrated aircraft routing and crew pairing problem here, okay, and this problem involves the airlines, okay, airlines service, right? So the aircraft is assigned to each flight legs and manage the sequence of flights to be flown by each aircraft type while satisfying the need, okay, of maintenance for each aircraft, right? So we need to find an optimum cost of route for all the flight legs, okay, from the given origins to the given destinations. And at the same time, we need to determine, okay, we need to assign, okay, the crew to the flight leads, okay, and also satisfying the constraints, okay, of minimizing the cost of the covered flight leads, right, in the schedule. Okay, this is the operational framework of the methodology, right? So it is a hybrid method. It is a hybrid method was used. Okay, first we use the constructive heuristic method, okay, to generate the aircraft routes and the crew pairs. Okay, then the generated aircraft routes and crew pairs was used, okay, as the input to the following models. Okay, so we have three models here: integer linear programming models. We have Bander's decomposition methods and also Denzik decomposition methods. Okay, we use these three types of models, okay, in finding the best one, okay, to be used for solving the problem, right? So here another one, okay. I think this is the last one that we'll share with you all, is on the antihypertensive drugs prescription, okay, to first-time stroke patients. Okay, so this is in a problem in healthcare, right? So different patients require varying strengths of drugs depending on their conditions. Okay, therefore the prescription, okay, the antihypertensive drugs prescription need to be done optimally, okay, in order to avoid any wastage of valuable resources. So this problem was formulated as a multi-objective mixed integer non-linear programming problem. Okay, and this is the results, okay, that we obtain from solving the model. Okay, as you can see, based on the condition, okay, based on the condition of the patients, okay, so the patient with MAP, initial MAP reading of less than 131, the drug combination should be just ACE inhibitors. Then if it is 132 to 148, should be ACE inhibitors and calcium channel blockers, and so on, right? Okay, so all right, so that are some of the applications of OR, okay, to various problem in the real world, okay, and hope you can see, okay, how OR works, okay, how OR is why OR is said to be the science of better, okay, because as you can see, okay, from the examples that I've shown you just now, that OR deals with improving, okay, or driving or improving the operation, okay, of an organizations, and also driving the efficiency, okay, of the operations in various organizations. All right, okay. So before I end my sharing session, okay, allow me to acknowledge, okay, UTM Center for Industrial and Applied Mathematics, okay, where the transdisciplinary research is truly practiced, okay, and also to research group on mathematical optimization on research group on mathematical optimization, okay, Department of Mathematical Sciences, Faculty of Science, UTM. Okay, the heart of transdisciplinary research. Okay, so thank you for listening. Thank you iADORE2020, okay, for having me. Okay, and to all participants, enjoy the rest of the symposium. Okay, and we welcome any collaborations, and do not hesitate to contact me at the email address given to you on the slide. All right. Okay, with that, thank you. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. All right, thank you, Dr. Zaitul, for the remarkable speech. Very interesting points in operational research. All right, so I would like to open for the Q&A sessions. All right, so any questions for the floor? So I check here. Okay, all right. Okay, because we are run out of time. So again, on behalf of organizer, thank you, Dr. Zaitul, and thank you also for your attentions. All right, so back to the host now. Thank you.
Thank you so much to the moderator. Ladies and gentlemen, we have come to the end of the first keynote session. We would like to thank our honorable keynote speaker, Associate Professor Dr. Zaitul Marizawati, for the informative sharing. And to the audience, we are going to have the second keynote speaker. So to all participants, please stay with us until the end of our session. Not to forget, please to register your attendance using the link provided in the chat box. So now we will have our second keynote speaker by Dr. Fera Yanuar from the Universitas Andalas, Indonesia. Without further ado, I will pass to the station to Dr. Zarina Muhammad Khalid, the moderator for the third keynote session. So Dr. Zarina, the floor is yours. Thank you.
Thank you very much to Ms. Norehan. Okay. Assalamualaikum and hi everyone. We are here at the second keynote session. I am Zarina Muhammad Khalid from the Statistical Modeling Research Group, Department of Mathematical Sciences, Faculty of Science, UTM. I'll be the moderator for this second session. Let me introduce to you our next keynote speaker. She is Dr. Fera Yanuar, an Associate Professor of Statistics at the Andalas University in Padang, Sumatera, Indonesia. She studied statistics at the Universiti Kebangsaan Malaysia, UKM, and received her PhD in 2013. Now she is a lecturer at Mathematics Department, Faculty of Mathematics and Natural Sciences, Andalas University. She has been the chair of undergraduate mathematics study program at Andalas University since 2016. Her research topics include quantile regression, Bayesian analysis, structural equation modeling, and small area estimation. Her ongoing research is currently funded by Research Directorate and Community Service under the Ministry of Research and Technology, Republic of Indonesia. Okay, Dr. Fera, are you ready now? Okay.
Hear my voice?
Yeah, I can hear your voice. So without further delay, let's welcome Dr. Fera on stage to present her speech.
Okay, thank you, Dr. Zarina, for your nice introduction. Let me share my slide first.
Yeah, sure.
Can you see it, my slide? Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable One, all committee of iADORE2020, and respectable all audience who join this virtual symposium. First of all, let's pray and thanks unto our God Allah Subhanahu wa Ta'ala, the Lord of this world, who has been giving us mercies and blessings today. So we have been granted this opportunity to gather international symposium on advanced statistical data analysis and operational research virtually. Secondly, may salawat and salam always be with our best Prophet Muhammad Sallallahu Alaihi Wasallam, who has guided us to know and do the right thing to live in this world, namely Islam, the religion which guides mercy to all worlds. Dear ladies and gentlemen, I would like to say thanks to the committee of iADORE2020 that have invited us from Andalas University to share in this symposium. We hope we could do any collaboration next time. Today, I'm going to share a topic in statistical modeling. The title of my presentation is Modified Quantile Regression with Bayesian Method for Optimal Variable Selection. In this talk, we did several comparisons between methods, which are modification or quantile regression. It's kind of theoretical statistics, actually. In statistical modeling, we usually have one or more indicator variable. We use X in popular. We are interested to predict the model between these independent variables into dependent variable Y. And the tools that we usually use to construct the model is ordinary square method, usually, where we look at almost or just interested in a conditional mean. But of course, sometimes we might wonder why the mean, why not the median? We could think of a model and in general, if we have skewed data, we cannot use OLS or median anymore. One of the tools that we can implement here is quantile regression. We could think of the tau percentile or the tau quantile as being linearly next. The quantile is the same as percentile, actually. Quantile regression fits percentile of the response, such as non-fit percentile, and it brings the familiar concept of a percentile into the framework of general linear models. Quantile regression was introduced 14 years ago by Roger Conker and Gilbert Bayesian, but only recently has become practical for any condition of data and for large data due to computational advances. Today is well worth knowing when we should use quantile regression. Let's start with a basic example. Here is a plot observation for two variables X and Y. The fitted lines was obtained using standard least square regression. Least square regressions models the conditional mean of Y, assuming it has a constant variance. But here, the variance increases with X. The green curves in this plot represent the conditional distribution of Y at 4 values of X. When the shape of the conditional distribution varies with the predictors, you need a flexible approach that models the entire distribution, not just the mean. And that's when we should consider using quantile regression. In this plot, the lines represent quantile regression models for the 10th, 15th, and 90th percentile of Y. By fitting models for even more percentiles, you can estimate the entire conditional distribution. Often, the answers to important questions are found by modeling percentiles the distribution. For that reason, quantile regression provides critical insight when valuable information lies in the details. Tools for fitting quantile regression models you may use such as R or STAT by using contract procedures. And here are the example in providing how quantile regression works. In this figure, the this figure is providing the plot of the coefficient estimates for a predictor that we found from the quantile regression. We look here that a solid red line is OLS estimate with 95 confidence interval, which is indicated by a red dashed line. This that the OLS line is flat along the quantiles in the x-axis because it cannot vary across the quantile. Meanwhile, these points are quantile regression estimated at various quantiles with great confidence interval. We look here that 0 points is not lies within the confidence interval, which is indicated that this coefficient is significantly different than 0. We can see that there is significant difference below OLS, and there is a significant difference above OLS for high quantile as well. Or we also could say that there is significant difference from OLS across the quantiles. What is the important things that I want to show you? That in quantile regression, we do not just model the average of response. Instead, we could construct the model at various quantiles that we want. We could build the conditional quantile of the response depend on predictors. Thus, here are some advantages of quantile regression, including it's flexible to model. We model the data with heterogeneous conditional distribution and robust to outliers. Second, it makes no distributional assumption about the error term in the model so that it provides efficient estimates of model coefficient under non-Gaussian condition. And third, it can estimate multiple rates of change or slopes from minimum to maximum of the response variable, providing a more complete view of the relationship between variables. This is especially useful in application where limiting factors or extremes are more important than the averages. These unique advantages led to numerous practical especially when there are many predictive variables or predictive problems. There are some challenges problem in variable selection in quantile regression, as the estimates some the density of the innovation terms, and it's not easy to compute in practice. And regression methods such as natural Revson methods cannot work well. And third, variable selection in quantile regression is not computational efficient because it needs highly time-consuming, suffer from instability and expensive computational costs. And thus, regarding inference procedures and confidence interval construction can be greatly simplified by using bootstrap resampling methods. And moreover, the bootstrap algorithms are computationally interactive and easy to use in practice. And here are several researchers. They use bootstrap resampling method in constructed and confident interval with the hybrid with quantile regression. The results from these studies showed that the bootstrap methods have finite sample performance for both location and location scale models. And these all methods could be employed easily by using our software. And researchers related to variable selection have been developing until now because of many limitations due in the results that researchers find in the study, such as the problem in for fittings rising quantile regression models recently. In this respect, the research area that has attracted much interest in variable selection considered to implement what we call is penalized likelihood. The high prediction accuracy and computational efficiency of penalized regression methods have brought them increasing attention over the last decade. The first use of penalization in quantile regression is made by Conker around 2004. The author developed an L1 regularization quantile regression method and shrink the value effect toward a common value. Then we were introduced with what we call lasso method. Lasso is stands for of least absolute shrinkage and selection operator developed by Tebsrani in 1996 as becoming widely used as an alternative procedure to the traditional quadratic loss function for parameter estimation in regression analysis that deals with the issues in variable selection. Today, the lasso is well-established method for variable selection and estimation for regression coefficient, and many extensions have been developed. And here are some pioneers in lasso penalized estimator. And there are also several studies in achieving the best model we can also use in Bayesian approach, since Bayesian has several advantages in estimation and variable selection. It also provides a possible approach for Bayesian inference on quantile regression. For example, Kozomi and Kobayashi 2011 consider quantile regression models using an asymmetric Laplace distribution from a Bayesian point of view. And here are the papers that use quantile regression with hybrid with Bayesian approach. In Bayesian terms, the lasso procedures can be estimates under independent Laplace priors for the regression coefficient. And here are some researchers that use Bayesian lasso approach in quantile regression. And what are the research questions in our study now is first, how to improve the performance of quantile regression confidence interval with bootstrap resampling. And second, how to improve the quantile regression models variable selection with modified quantile regression. And then how to test the algorithms acceptability in order to implement the proposed method to generated data. And then we employed the proposed method to the empirical data regarding the length of hospital stay for patients with COVID-19 in West Sumatra. And we want to model what are the best models. And here are the research objectives we identify based on the research question as we mentioned before. And the methodology that we use in this study are from quantile regression. Suppose that we have y as a response variable and x as the covariate. And for tau from 0 to 1, q of tau for yi depend on xy, denote the tau quantile regression function of yi with associated p-dimensional vector of covariate x. The quantile regression function is expressed in this form, in this equation. And then we can construct the linear quantile regression model can be expressed as this equation. And then quantile regression estimation for beta as the parameter that we want to estimate is obtained by minimizing this argument, where rho tau of u is the check function defined by this equation. Here, function of I is an indicator function that takes the value of unity when function of I is true and 0 otherwise. However, this indicator function is not differentiable at 0, and explicit solutions of minimization problems are obtainable. Thus, in quantile regression methods, linear programming is often implemented for parameter estimation. And in this present study, we implement the Bootstrap Resampling method to estimate the parameter model. 5 options of different Bootstrap methods are implemented in this study by using empirical data regarding COVID-19 data. We compare the result of these 5 options and then determine the best one. Basically, all methods start from Bootstrap resampling methods in quantile regression. Each method then needs a modification to Bootstrap quantile regression approach, and we will apply all 5 methods to the data, to the empirical data. This is the step forward Bootstrap quantile, which we imply then in our empirical data. And then we also use Bayesian quantile regression in our study. Based on study by UNAND Moya 2001, they found that minimization of this argument is equivalent to maximizing a likelihood function of yi. It's assumed that yi has skewed Laplace distribution with parameter mu, delta, and tau with corresponding probability distribution function is given by this, where is equal with this parameter. One of the skewed Laplace distribution's attractive properties is that it can be expressed in various mixture representation, such as scale mixture of normal distribution constructed by Hamzawi 2012, where Zi here have exponential distribution with parameter 1 over delta, and C here has standard normal distribution. This mixture representation allows us to express quantile regression models as a normal regression model. In addition, it provides an easy way to construct a gift sampler as well as saving time in sampling the regression coefficient. And in Bayesian quantile lasso regression, we based on the definition of the lasso estimate in quantile model, are defined as this argument. In this argument, we have this term is a L1 penalty quantile regression. As a non-negative regularization parameter lambda increases, the lasso estimates continuously the string's quantile regression coefficient towards 0. And as we know that in Bayesian approach, we also need prior distribution for the parameter that we want to estimate. So in this study, we choose Laplace prior for distribution of the data. And in Bayesian adaptive quantile lasso regression as the third modification of the quantile regression in this study, we put different penalization parameters on the different regression coefficient. Therefore, the new proposed Laplace prior for beta we construct is formed by this equation. And that equation can be represented as a scale mixture of normal with an exponential distribution, such as like this equation. Then we consider the class of inverse gamma priors for lambda square in the form of this equation. And to obtain the parameter estimate by using Bayesian approach, we have to determine the posterior density function, which is we obtain by combining this equation and this equation. And then the result, we then applied the proposed method to the data regarding the length of mortality of patients with COVID-19 in West Sumatra. And in the primary analysis, we get that the data is very skewed. So that's why we use quantile regression approach in this data. This model consists of diagnosis. Diagnosis is the categorical data consists of 4 categories: gender, residential address, occupation, also after hospitalization, average age and comorbid, average age and comorbid is in continuous type of data. And if we include all the parameters, all the variable in the model, we have to the power of 17 minus 1 combination models. It's so many models that we want to construct, that we want to estimate. And then by use the variable selection, by using quantile regression approach, we reduce model and we find that diagnosis and status after hospitalization tends to result the best model. And then we applied the bootstrap quantile regression to the model, to the data. And we choose the quantile 0.1, 0.25, and 0.50 and 0.75 to the XY pair method, PWYIS method, Monte Carlo MCMB method, WXY method, and the WALT method. And here the result of our bootstrapping quantile regression. This one is the value of the estimate mean of the quantile regression, bootstrap quantile regression for 0.5 with the 95 confidence interval and standard error in this slide. And we got that the while bootstrap quantile regression tend to result shorter width of 95 confidence interval and the smallest standard error. And based off the and then we can conclude here that the wild bootstrap quantile is the tend to produce the best model in bootstrapping resampling method. And then based off the wild bootstrap resampling, we construct this estimate coefficient for length of stay patient with COVID-19 with 95 confidence interval. And this figure presenting the OLS estimated with its upper bound and lower bound for 95% confidence interval, which is indicated by solid and dashed red line. Meanwhile, the quantile with confidence interval estimated at any sequence quantiles are shown with gray area. This figure informs us that width of 95 confidence interval based on OLS estimates are wider than quantiles, especially at lower quantiles. Based on ANOVA test, we also could conclude that there are no significant coefficient difference between OLS and quantiles, especially for lower quantiles to higher quantiles, such as at 0.8 quantile. This fact could be also mentioned in this figure. Such as positive plot here, it seems that no significant coefficient between OLS and quantiles at lower to higher quantile. In addition, comparison among quantiles are also based on ANOVA test as well. The quantile regression coefficient associated with positive is significantly different between 25th quantile and 75th quantile. And then we got the study to the simulation study to implement the proposed method, what we call modified quantile regression. But before implement or import the proposed method, we have to test the algorithm acceptability for proposed method first. In this test, we use generated data, and this here our hypothesis model. We construct three in the predictor here. Beta is 1.5 and 3. And we also construct three different distributions for EI here. We're considered as heteroscedastic normal, and then autocorrected error and non-normal error. And for each choice of this distribution, 100 simulations were carried out. In each simulation, 150 observations were generated to assess the sampling efficiency of the proposed algorithm. The Monte Carlo standard error for each beta p from 1 to 3 were calculated by running the KIP samples for 20,000 iterations with an initial burn-in of 1 1,000 iterations. Then the length of 95% bias credible interval was estimated for each selected quantile for each proposed method. The absolute mean bias, the absolute bias is also estimated when the estimated of beta G were compared with the true value of beta. And here the result for our first condition of error is the heterogeneous error here. A table here above, table here present the absolute bias and length of 95% Bayesian credible interval for 3 parameters, beta 1, beta 2, and beta 3 for heterogeneous error condition. The result show that all values of the absolute bias for corresponding quantiles are almost similar. Notice that Bayesian adaptive lasso quantile regression yield the smallest values among the other 3 methods except for beta 3. The bias credible intervals for all proposed methods at the same quantiles are almost interval for Bayesian adaptive lasso quantile regression is shorter than the other 2 methods. The result concerning 3 different error distributions inform us of 2 things. And in this one, we also get the same result actually for non-normal error condition. And based on this various condition of error, there are two things that we could inform us. That first, although the performance of all the 3 methods proposed in this study is very close in general, the Bayesian adaptive lasso quantile regression method performs better than the bias lasso quantile and bias quantile method. And these results also inform us that Bayesian adaptive lasso quantile regression method is robust to the violation of error distribution assumptions. Thus, we can conclude here that the Bayesian adaptive lasso quantile regression tend to be the best estimator method compared to the other method. And then we also have to do the convergent diagnostic of the parameter estimate to make sure that the parameter model represent the true value. And this figure A, that generated samples lie within 2 parallel horizontal lines centers at values and no trend are detected. And in these histograms of marginal posterior in figure 7b also informs us that the conditional posterior distribution are the desired stationary univariate normal. And this distribution, posterior distribution, range at the true parental value threshold and the density plot. And furthermore, in this figure C is providing that the decrease of the empirical autocorrelation of posterior samples, which are proof that no autocorrelation happened in sample data. The almost same result were obtained with other 2 conditions of error. The results obtained from these convergence diagnostic plots indicate that our algorithm used in Bayesian adaptive lasso quantile regression could produce more adequate and acceptable values of the estimated parameter compared to the other 2 methods. And then after we obtain the algorithm, the acceptable algorithm, we employ the algorithm to our empirical data. And here the result of our implementation of the proposed quantile regression in construct the best model regarding length of hospital stay of patients with COVID-19 in West Sumatra, Indonesia. And we select the quantile at 0.10, 0.25, 0.50, 0.75, and 0.90. You may choose any quantile that you want. It depends on the researchers. And we look here that for quantile 0.1, the Bayesian adaptive lasso quantile regression tend to yield the smallest or the shortest length of 95% Bayesian confidence interval for all parameter model here. And for this quantile 0.5, we also get the same value that the quantile Bayesian adaptive tend to result the shortest confidence interval in Bayesian credible interval predictor. And for the quantile 0.75, also we get the same result. And the quantile 0.90, we also get the similar result. And what is the conclusion? And then, sorry, before we go to the conclusion, we have to do the convergent diagnostic test for the proposed model. That here the result of our convergent test. We saw in this plot that all of the parameter estimates have converged, and it means that we can receive this model. Example, in this quantile 0.9, that person under supervision, and then patient under supervision, and then positive patient, and this the status for after hospitalization are could predict the length of hospital stay for patient with COVID-19 in West Sumatra. And what are the conclusions that we can conclude in this study? First, to improve the performance of quantile regression construction for confidence interval, we can use, we could implement while bootstrap quantile. And then we standardized lasso quantile. Sorry. And then Bayesian lasso quantile regression tends to perform well compared to other methods. We test it by using simulation study and the empirical study. And the last one, after we implement our proposed method to the empirical data regarding the COVID-19 data in West Sumatra, we got that the length of hospital stay for patients with COVID-19 in Sumatra affected by diagnosis and status after hospitalization. I think that's all for my sharing today. Thanks for seeing my presentation. Thank you very much. I back to the moderator. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi. Dr. Farah, thank you very much for your very interesting and exciting thought, especially when it relates to cases, hospital stay, to those COVID-19 positive in Sumatra. So now I open the session for question and answer. Let's see if we have any question in the chat room. Okay, no questions so far. So Dr. Farah, let me ask. Yeah, okay, we have a question here. Dr. Hasinor, maybe you want to ask question? Yeah, please. Yeah, Dr. Hasinor, maybe you want to on your mic.
Yes, thank you very much. Can you hear me?
Yeah, very clear.
Okay, thank you. So I would like to ask one question. Do we know that adaptive lasso exhibits oracle property? I don't know whether Bayesian adaptive lasso for quantum regression proposed by the author also exhibits the oracle property. So this first question, and I have another question.
Dr. Hasina, maybe you can repeat your question clearly, please.
Okay. So whether this proposed Bayesian adaptive lasso method exhibits oracle property. We know normally the lasso exhibits oracle property. It means it can do the sparse variable selection and also consistently. So I would like to know from the speaker that whether their method also exhibits oracle property. This is if it is not clear, then I have another question. Like we know the Bayesian method depends on the prior. So the sensitivity of the prior, whether the speaker checked for this Bayesian method. Thank you.
Okay, Dr. Farah, can you hear the question clearly?
Okay, actually the first question, I haven't got the point yet, but I'll try to answer the second question. To check the sensitivity of the prior and the Bayesian approach, is it? Yes, in this research, actually, we choose Laplace beta parameter estimation based on the previous study. And then we just look at the sensitivity of the prior after we got the model after we got the purpose model. We check the bias, we check the length of the confidence interval, and we compare it with the others methods. In the study, we choose Bayesian quantile and Bayesian lasso quantile regression. And then we compare with the Bayesian adaptive lasso. And then to check the sensitivity, we just look at the convergent diagnostic test by look at the trace plot, density plot, and the autocorrelation plot. And after we got the result, and we check that all three diagnostic tests present the acceptable reason to accept the proposed model. So we conclude that the prior is could be implemented in this Bayesian approach. And moreover, in Bayesian, we could choose any prior, whether informative prior or non-informative prior, conjugate prior or non-conjugate prior. And the study based on because we got from the previous study, so we implement the informative prior in this study because it got from the previous study. I think that's all for my answer.
Thank you.
Okay, any other question from the floor? So hopefully Dr. Hasina is satisfied with the answer. Maybe for the second question, right? For the first question, I myself is not very clear. Yeah.
Yeah, I don't get the point.
Okay, I just wonder, why did you use Laplace prior in the first place? Is there any reason for that?
In Bayesian approach, we got the parameter estimate by implement the what we call posterior distribution that from the likelihood function and the prior distribution. And this study based on the study by U 2012 that the response or the data is skewed Laplace distribution for the data distribution. And we know that to get the beta estimated data, we should to implement the conjugate prior. So That's why we choose Laplace distribution, as we know that Laplace is the quantifier of the skew Laplace distribution. And moreover, it comes from the idea from the previous study actually.
Okay, well, thank you very much, Dr. Farah. Okay, it's very interesting to look at your research where you straight away apply onto the latest real data from hospital. I just want, and it's very good for you that you can collaborate with the hospital teams on this. So if there is no further question, I think we are at the end of this session. So I would like to, on behalf of organizing team, I'd like to thank again Dr. Farah Yanor for a very interesting talk, and hopefully we can collaborate in the near future, inshallah. So we will see you again very soon, yeah, inshallah. So and we will have a short break after this. So I would like to inform the attendees, please stay put. Okay, and we will have another session after a short break. So I pass this session to our host. Back to you, Narahan. Thank you, Dr. Farah.
Welcome. See you.
See you.
Okay. All right. Thank you so much to moderator, and thank you to Dr. Farah Yanor for the amazing sharing. For our participants, we will have a break for 15 minutes. For UTM students, the QR code will be shared. Please scan the QR code for student accept merit. See you all again at 11:50 Malaysian time. Thank you for your attention and see you. Assalamualaikum and have a good day. Assalamualaikum and good afternoon. Welcome back to iADORE 2020. We will have our third keynote speaker by Professor Dr. Muhammad Ishamli from Universiti Teknologi Malaysia. Thank you for staying with us. Hope all participants will get the knowledge from the speaker. Allow me to remind you once again, the registration link is in the chat box. Please do register your attendance using the given link. So, I will pass the session to Dr. Arina Bazila Kamisan, the moderator for the third keynote session. Thank you.
Okay, thank you, Norehan. Okay, Assalamualaikum and very good afternoon to everyone. Okay, I am Arina from Department of Mathematics UTM. So, I will be the moderator for this talk. So, for this session, our keynote speaker will give a talk entitled High Dimensional Classification by Sparse Binary Logistic Regression with Weighted L1 Norm Penalized Likelihood Method for Feature Selection. But before that, I would like to introduce our speaker. So, Prof. Dr. Muhammad Ishamli was born in Malaysia. He holds a degree in BSc and MSc of Statistik from Universiti Kebangsaan Malaysia and PhD in Mathematics from Universiti Teknologi Malaysia. He has been with UTM since 1991 and currently serving as Professor of Department of Mathematical Sciences UTM and as Deputy Director of Analytics and Institutional Research for Office of Strategy Management, Office of the Vice Chancellor UTM. So he has more than 25 years of teaching and research experience. He has contributed more than 100 research papers that are published in reputed journals and conferences. So before we start this session, I would like to remind, if you have any question during this session, you can leave the question in the chat box or you can ask during the Q&A session after this talk. Without any further, I would like to welcome Prof. Ishamli to share his talk.
Can you hear me?
Okay, Prof, here. Very clear.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Wassalatu wassalam ala rasulillah wa ala alihi wassabi ajma'in amma ba'. Thank you very much. Terima kasih moderator Dr. Arina for the kind introductions. Good morning to all my friends, ladies and gentlemen, colleagues and students. Thank you very much for attending today's sessions. I'm sorry for the hiccups due to some technical issue until need to be postponed until now. First and foremost, I would like to congratulate UTM, also University of Dhaka, Bangladesh, and also Universiti Andalas, Indonesia, for successfully organized these international symposiums on advanced statistical data analysis and operational research, so-called iADORE2020. Sorry, I have some technical issue. I cannot share my videos. So we try since 9 something until now, so still not successful. At least we have the voice still working. So indeed, we know that enhancing statistical data analysis and also operational research skill is essential for nations to ensure relevancy in the modern era, particularly in the pandemic's current new norms. So this conference deems as prompts and also appropriate in addressing essential aspects of enhancing statistical data analysis and operational research. A huge congratulations to Symposium's organizers. I acknowledge it takes much hard work to make this symposium a successful and memorable event. Therefore, I would like to congratulate the organizer team members for the extraordinary setup. So indeed, all participants can benefit from this event. Surely this conference will inspire creativity and also innovations. A big congratulations again to UTM, Universiti Dhaka, and also Universiti Andalas for a well-organized conference. So I firmly believe this is an excellent opportunity for researchers to check out the latest advancements in data analysis and also operational research. And this open up opportunity also for transdisciplinary research collaboration among us, especially these events is co-organized by 3 universities. It's a great pleasure to meet everyone here today and meet other keynote speakers of these symposiums. So, and also I would like to express my gratitude to Dr. Nohaiza Ahmad and his team for inviting me to these remarkable events. So today I will speak about one of the works I have done recently with my colleagues and PhD students. So I will start off with the backgrounds research or research backgrounds. So new applied science advancements have made a classification a huge high-dimensional features a strong interest in recent scientific investigations and also in applications. Feature selection is a common known issue in sparse logistic regressions. Researchers introduce regularization techniques such as the least absolute shrinkage selection operator, or normally we call as lasso, and also other methods like SCAD and also additive lasso to shrink the regression coefficient towards zeros. High-dimensional data refer to a situation where the numbers of explanatory variables exceed the number of observations in a data matrix. Here are some of the example application of high dimensionals with the high dimension data using sparse logistic regressions. So you can see the application in genomics, chemometrics, pattern recognitions, achromatic, and so forth. So sparse logistic regressions is important in many scientific research areas. So basically explain the relationship between the response variables of interest and also the number of explanatory variables. When dealing with high dimensional, the design metric X normally will have the situation where more columns than rows, okay? Column normally people will denote as P and row will be denote as N. And normally you encounter issue like multicolumnarities, and also the metric is singular. You can refer some of the citation there for more details. And in terms of the challenges is that we can see the traditional estimation method, such as the OLS method, tend to perform poorly due to the columns is more than the row, or the P is more than the N. And also have, in terms of the Hessian matrix, is not full ranks, and the iteration metric to get the estimation like Newton-Raphson methods cannot work. Okay, we also have the issue including like overfittings, estimation, instability, predictions, interpretation, and so forth. So these are some of the issues surrounding the sparse logistic regressions. As mentioned just now, variable selection is one of the important aspects. So it plays a vital role in sparse logistic regressions with high dimensional data. So basically the idea is to select only a subset of important variables. As the research problems, so penalized method have a drawback, right? Such as have biases and also inconsistencies. They lack in their oracle properties, and also in terms of encouraging groups effect, robustness, and also the estimations. Okay, using OS or MLE, neither correct in using their initial weights. And so forth, basically new to the P is greater than the N's. Then we have the penalized estimation method like lasso, elastic net, and so forth, is inconsistent variable selections. Then the large coefficients also can cause the L1 norm bias, okay, because large coefficients will make more considerable penalties. So these are some of the things. As for this research or this study, so the research questions will be something like something here, okay. So how to propose adaptive penalized methods instead of the existing method. Basically, try to improve in terms of the prediction accuracy. What is the significant gains then achievable? Okay, and what is the best criteria for performing the proposed method and how they can be carried out? Okay, all this information will be given after this. How can the proposed adaptive penalized method be applied in the real life? So this one also will be given. So for today's talk, hold on, let me push it. Okay, research aim. So this study aims to determine the sparse logistic regression modeling's accuracy. So we will look into the accuracies on microarray gene expressions, okay? And also the research objective here is, first, we try to improve the sparse logistic regressions, model variable selections with an adaptive penalized techniques. And also we're going to compare the proposed method, okay, with the popular penalized method such as lasso, scut, and also adaptive lasso, and other method also to assess the proposed method classification performance. So we're going to look at the performance with other penalized methods, okay, using performance metrics such as classification accuracy, sensitivity, specificities. Here is the penalized methods, okay. Penalized method has shown to be successful in handling high dimensional data. So the issue using the classical or traditional will be overcome using the penalized method. So the idea is shrinkage. So shrinkage is done by imposing a size constraint on the parameters as shown here, okay. So this is the penalized or the penalties here. So lambda j beta here is the penalty terms, okay, which depends on positive tuning parameters. A solution for performing variable selection and model estimation in high dimensional data simultaneously. So this is one thing good about the methods, okay, is they can do simultaneous for variable selection and also model estimations. Penalty terms added to the likelihood functions. Okay, basically the idea is to control the complexity of the models and also to provide criteria for variable selections. Okay, and other thing is this constraint force the parameters to be exactly zero. And also other thing is the amounts of penalties terms is the trade-off between the variance and also the bias, okay, of the selected models. So how the trade-off work as mentioned here. So the amount of penalty term is the trade-off between the variance and also the bias. Okay, so the idea is that the small amounts lead to select more explanatory variables with little bias. So you can have more variables here, but with little bias. But this going to give you a high variance, or a large amount lead to select few explanatory variables. So you're going to have few here with high bias. Okay, this will lead to a less variance. So a good choice for the amounts of penalty terms will improve the prediction accuracies. Okay, and make an easy interpretable models. Several models or techniques have been proposed regarding the penalized method. The famous one is the ridge regressions, okay, introduced back in 1970. So it overcome issue in terms of congruity. So the string the regression coefficient towards zero by adding L2 norm penalties, okay, and hence the variance, okay, of the parameter estimate are reduced, okay, and also as a trade-off, the estimate parameter are biased. So applicable in high dimensional, it can be used. It does not have the capability to perform variable selection. So this is so again, next is this method, what we call as lasso, introduced by Tipsharani back in 1996. So the adding a L1 norms penalty to the likelihood functions. So this can perform variable selections by assigning some explanatory variable coefficient to zero. This method also has some shortcomings. So first is cannot select more explanatory variable than the numbers of observations. Select one variables among the high correlated variables. Also does not have the oracle properties. Okay. We also have other methods like elastic net, okay, correlated base penalty, additive lassos, okay, by Zhao 2006, okay, and also other methods like additive elastic net and so forth. So there are methods, new methods introduced. Okay, so now we go to the formulations related to the methods. Okay, the methodology sections. We have this one I mentioned. This I mentioned about the ridge regressions. Okay, so this is the formulations, and for lasso, this is the formulation. You can see the difference in terms of the penalties. Okay, well, here is the beta square. Here you have absolute. Additive. This is additive by using the weights. Lasso cannot select more P than N. Okay, lasso try to select one variable among correlated variables. So there is group of correlated variables where there is a group of correlated variables. Lasso does not have the oracle properties, right? So so we're going to start off the penalized logistic regression here. Okay, first we're going to suppose or let Y be a Bernoulli random variables with a parameter P. Okay, so you have P variables here. Then going to have X1 until Xn be the independent random sample of X. Then we have the response variable Y has a Bernoulli distributions. So this is the formulas. Okay, so I is 1 until N. Then we can have the conditional probability of Y, okay, equals to 1 given by X. So this is meanings because we are dealing with logistic regressions, we're going to have two events, okay, for this particular work. So you have 0 and 1. So this is the formulas until 1 until P. So this is the likelihood functions of the sample. Okay, so this is likelihood functions, the formulations here. Then we have the log livelihood functions. Okay, so this is the things here. Then we have the penalized logistic regression models. Okay, is defined as this one. So we have the penalized here. So we have this plus the penalty term here. So lambda j beta. So lambda basically is a tuning parameters, is always positive value or greater than 0 equal. So you have the j beta is the penalty function there. So if L1 penalizations of lasso is this one, then it become lasso, okay, for these terms there. So it's as introduced in tips already. Okay. This is the maximal likelihood solutions, okay, for beta head for lasso. So this is the formulations with sparsity properties, okay. Cannot select more than n variables, so cannot make group selections, equal penalties of all variable coefficients, making bias in variable selections, and also lack of oracle properties. So this is the additive lasso, okay, introduced by Zhao. Okay, so this is the additive, this formula. Okay, so this is the part of the penalties. Like you have the lambda there, and this is the one here. So lambda, and also you have the gamma here is a positive there, or more than 0. So this is the initial estimate for each beta j, okay, estimated using the lasso techniques. And different weights are used to penalize difference coefficients in L1 norm penalties. Okay, this is our proposed method. Okay, so Wj is the weight inside the L1 norm as follow. So you have Wj there. So this is the j here. So this is the weight for each predictor variables. J, that is defined as something like this. So as you can see here, the xj here, okay, denote the column j across rows, okay, and the sigma here, okay, sigma here basically is a summation of these two, okay, the first one and the second one of the sigma. So denote the weighted variance of column j across column, so belongs to class K2. So we are looking at binary logistic regressions to the K equals to 2. Okay, so that's why you have 2 here only. So this is the weight. So right. In terms of computational algorithms for this method, they introduced, we put in the name as additive, penalized, logistic regressions. Okay. So this is the first, we categorize each independent variables, okay, based on the values of y, so into 2 classes, okay. So we're going to find the mean, okay, for the first group and the second class. So then find the variance, then compute the weighted variance here, and also compute the j. After that, we're going to find the wj, okay. So after that, you can define this one, okay, xj here. So the solution is this one. Then basically, we can solve this, okay. So all the information here is already available. Luckily, the additive penalized logistic regression equations have a convex forms, okay, which ensure a global maximum point can be achieved and can be efficiently solved, okay. The coordinate descent method can be used to solve the APLR. Okay. So I'm going to show you an example here, the data set descriptions for the data that we're going to use to illustrate the methods. So this is the breast cancer data, okay, collected, okay, containing 569, whereby we have 15 cases are normal, and 339 cases are malignant, okay, patients. Yeah, I think this one I forgot to update. Let me see. Yeah, probably. So this data can be obtained from basically from here, okay, and the information details, basically from these papers, we can get the data, and the data set itself, you can get it from UCM machine learning data set repository. In terms of performance evaluations, we're going to use the classification accuracy, the CA, sensitivity, this is the formulations, and also the specificities, okay. So this is the formulation method we're going to use. So the idea is that higher of the value of the use evaluations criteria, the better classification performance is, okay. So basically we are looking at a higher percentage. If you have a higher percentage of these three, or either one, so you consider better. Experimental setup, okay. So the experimental randomly split descriptor molecule into two partitions. So we are going to have a training data set and also the testing data set for cross validations process, okay. So the split is 70-30. The experiments use 10-fold cross validations and average 100 partition times, okay. So there's a repetition there. The tuning parameters value will be between this range, okay, depends on the training data set. The experiment set, the constants for the A is 3.7. So we're going to use this one as mentioned or recommended by Fan and Lee, okay, for SCAD penalties. This is the performance evaluations of penalties techniques, okay. So we have the lasso SCAD, also additive lasso compared with the penalized. So this is for the training data set performance, okay. So as you can see the features or the variables selected, this is 13, this is 14 and so forth. This is classification accuracy, this is a percentage as mentioned, higher is better. Okay, this is the standard deviations. This, okay, specificity and so forth. So you can see that APLR method provides a lower number of feature selections, and also this method able to provide a better accuracies in the classifications. As you can see, this percentage, okay, is higher. After that, we going to test for testing data set performance, okay. So we look at the testing data set. So we're going to repeat it again. So this is the performance evaluations, as you can see. So you can see the percentage is higher for the testing data set. So what we can conclude here is the proposed method able to provide better accuracy in the classifications. And also third, we're going to have a comparison using a pair t-test for classification accuracies. So we're going to test the proposed method with lasso, the proposed method with SCAD, and also the proposed method with additive lasso. So we're going to look into the training data set and also for the testing data set. So in terms of the improvement, the difference of the improvement is this is the percentage, and this is the p-values. So you can see that basically all here is significance. So there is a statistically significant difference between the proposed method, the additive penalized logistic regression, and other methods at 5% significant levels. After that, I'm going to show you the comparison with other methods, okay, related to breast cancers, okay, with concerns. This is the data set, okay, same things. We have 10-fold cross validations. The method has been, or the accuracy methods have been available in these articles by Kadams, okay, 2019. So this is a method, this is the author, and this is accuracy, okay, that have been given in these articles. You can see that this is the, and this is methods, okay. I'm going to continue here. We have 10 methods here. So we're going to continue. So here is the 11 until 20 here. So this is accuracy, and also and so forth. So I'm going to show the last one. So okay, so this is the proposed method. So the accuracy is 98.90, okay, compared with the other methods, okay. So this is a conclusion that we can make, okay. So this study aimed to determine the sparse logistic regression modeling's accuracy on microarray expressions, okay, high dimensional features. So we propose the sparse logistic regression model feature selections with weighted L1 norms, additive penalized method based on high dimensional data sets. Okay. And we compare the proposed method with popular penalized methods such as lasso, scan, and also additive lasso. The experimental result shows the superiority of the proposed method over other techniques such as this technique, especially in the number of selection descriptors and classification accuracy, specificity, and also sensitivity and also the specificities. So for further details, okay, you can have a look at these articles, okay, published, okay, in this year, and also some of the related publications that we have done since 5 years ago. Okay, some of the details here for high dimensional data. If you require any of this article, you can kindly approach me. So I've more than pleased to give you the articles. Here are some of the publications related for these areas. And this is my research team members. Okay, we have Zacharias and Dr. Abdul, okay, Yusrina, and also I, related to research in high dimensional data. So with that, I would like to thank the organizers, okay, for inviting me to these symposiums. So I'd like to congratulate the organizer who organized this. So with that, I would like to end my presentations. Thank you very much. Wabillahi taufiq. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Okay, waalaikumsalam warahmatullahi wabarakatuh, Prof. Thank you for your sharing. So now I would like to open the floor for question. So anybody has any question regarding this topic? So I can see there is one question from the chat box. Okay, why have you used 30% as test data rather than 50%? Is there any reason?
Oh yeah, rule of thumbs, normally people will use 70-30, okay, or 80-20. So this is the norm because we need more data to test, to train the models. Then to verify it, to cross validations normally is 30%. That will be the, you can see this kind of ratio in many publications. I seldom or never come across that people doing 50-50s in articles they publish in good journals. So normally it's 80 or 70s. So if you use 50, I think if you publish, then you're going to have problem in terms of trainings probably. Thank you.
Okay, thank you, Prof. So I hope Dr. Hasinur, Prof has answered your question. Okay, so I hope you're satisfied with the answer. So any other question from the floor? You can always turn on your mic, or if you can also write down your question in the chat box. So no more question?
So thank you, Dr. Arina.
Okay, Prof. Okay, so with that, I think we can end our session. So on behalf of iADORE2020, I would like to thank Prof. Hisham Lee for his willingness to join this symposium and share his research with us. And thanks also to every participant that joined this talk. Okay, so I pass the floor to the host, Mr. Ridwan, okay, for our next session. Okay, so Assalamualaikum and have a good day. Bye.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you to our moderator, Dr. Arina Bazila Kansan. And once again, thank you very much to our speaker, Professor Dr. Muhammad Hisham Lee. Now we are getting ready for the next session. The next session will be a showcase skill by Dr. Arina Bazila Aziz. Now, before we get started, let me just share QR code for UTM students to make sure that you scan the QR code to register for this session. So so this is the QR code. Make sure you all scan. We're just going to leave it at that for a few minutes, and then I'm going to pass it over to our next moderator, Dr. Hang. Dr. Hang, are you ready?
Yes, I'm ready.
Okay, Dr. Hang.
So, can we start or wait for the scanning the attendance?
We're going to wait a few minutes for the attendance. In the meantime, I think we can just leave it. I think you can start, Doctor. Once you are done, I will pass the presenter to Dr. Arina. While you are moderating, I will just leave the QR code there for the students to scan.
Okay, thank you.
Okay, so without further ado, I will pass it on to Dr. Hang for the next session. Thank you.
Hi and good afternoon, everyone. Welcome to the first 4 case sections on simulation using Simulate in iADORE 2020. Before we start the sections, let me introduce myself as moderator and Dr. Arina Bazila Aziz as the speaker in these sections. I'm Hang Sipeng from Research Group on Mathematical Optimizations in the Department of Mathematical Sciences, UTM. Our speaker today, Dr. Arina Bazila Aziz, is a research fellow at UTM Center for Industrial and Applied Mathematics. She is also a senior lecturer in Department of Mathematical Sciences, UTM. She did her Bachelor of Science in Industrial Mathematics in UTM. In 2014, she received her Master of Science in Decisions Modeling and Information System from Brunel University, UK. Her PhD in Operation Research focused on inventory routing problem, awarded from Universiti Malaysia. Other than inventory routing problem, she is interested in queuing system and simulation. Now, we would like to welcome her on stage to start the sections.
Assalamualaikum. Okay, can I start now? Alright, Assalamualaikum and good morning or afternoon to everybody here. Thank you, Dr. Hang, for the introduction earlier. Okay, so today, let me share the screen first. Okay, so today I'm going to present a showcase on Simulate. Okay, simulation using Simulate. So before that, let me introduce myself. I'm Dr. Arina Bazila binti Aziz, and in Department of Mathematical Sciences, I'm a senior lecturer. And I'm also a research fellow in UTM Center for Industrial and Applied Mathematics. Okay, I am also a research member and I'm also the research leader in the research group on mathematical optimization. Okay. So today I'm going to present to you on Simulate. Before that, let's just a quick description, explanation on what is simulation. Okay, so simulation is something that we do to imitate the system of a real world problem. Okay, so we do that.
So we do that to understand and to estimate the behavior of the system. Okay, so how do we do that again? We do the observation, okay, by developing a simulation model of the system. Okay, so our system can, our simulation can be continuous, time or discrete event. So why do we do the simulation? Okay, so these are among the reason to why we do the simulation. First, because we want to do the risk-free experimentation. Okay, so the risk-free is if we do not have the system yet, but we want to see whether will it work like this. Okay, how many machines that we have to provide to make sure that the system can work smoothly, for example. So without having to really have the real system, we can just use the simulation to do the experimentation. Okay. Another reason we do the simulation is to avoid human mistakes. Okay. For example, in the explosion of Chernobyl nuclear reactor, okay, it occurs because of the human mistake in designing the nuclear reactor. So that's why instead of just waiting to having the real system first, let's try and do simulation. Also, we can do the policy testing and system design prior to implementation. Another reason for doing simulation is because we can avoid unnecessary spending. Okay, so that before we purchase a machine, we can always do the simulation first, whether it is necessary or not to have this machine or not. Is it going to help us to optimize our process? And then we can do the simulation to observe the highly complex system, okay, where we can do the analytical solution. We can also experiment on the current system, okay, if we already have the system and then we want to investigate on how can we improve the system, we can also do the simulation. For example, we can determine the important variables in the system and then predict the system performance if we change the variable. So these are among the area where we can apply simulation. Okay, so we can apply simulation in supply chain problem, where we can help to identify the inefficiency in our route or in our inventory system. We can also apply in healthcare, where we can plan the minimization on the patient's waiting time. Thus, we can help to increase the satisfaction of our customer. Okay, in healthcare also we can plan the staff management by doing the simulation. In the call center, we can use the simulation so that we can see how our customer service system operates, okay, whether the waiting time of our call is optimal or not. Okay, we can also do the simulation of manufacturing, okay, to see the process and optimize the process improvement. And lastly, another area that we can do in simulation is the automotive area. Okay, you can many website that you can go see. For example, in Simulate website here, we can also see the applications in industry, okay, by Simulate, and you can also see the case study related to simulation in this Simulate website. Okay, so I encourage you to, if you are interested in this area, you can also go here and read on the problems available.
Okay, these are the simulation software available. I only have experience using Simulate. Okay, I have never tried software here. Okay, but I know that Arena here, it is quite common to many people. I've seen it, but I never tried this. Okay, I use Simulate. So why I choose Simulate? Okay, the first and foremost reason, this is the software that I learned when I did my master degree in Brunel University before. And I find that this software is very user-friendly. Okay, it's very user-friendly. I can just do drag and drop all the objects in my software, and then I can do the settings and run. Okay, it's quite different than using C++. Next, I find that their support team is very efficient. Okay, whenever I have problem, I can just email them and I will get the reply very quick. Okay, so I feel very comfortable dealing with their support team. And then Simulate for Education here is very interesting because I can only purchase it for one time. And then I find that it is the cheapest among other simulation software. Okay, so this one-time purchase is one time, and after that every year we have to renew. Okay, just email the support team and they will renew our license. So one of the benefit of having the Simulate for Education here is the tutor will get the Simulate Professional, okay, and the students will get the Simulate Education, which valid for 3 months for them to use. And Simulate also have the online access, okay, so but I already tried, not as smooth as using the software installed in our computer, okay. All right, so let's start. Because I was afraid that if I show you the demo directly from the computer, there will be a lag or something like that. So that's why I chose to create a video for you to see. Okay, so maybe you can watch this video, and later if you have any problem, you can ask me later. Hi. Before we start building the Simulate model, let's have a look at the basic objects that we will use in our Simulate. So this is the example of the questions that we can refer to when we try and create the basic model in our Simulate. Okay, so let's look at the items or objects that we will see here in Simulate. Okay, so this is the main dashboard, okay, where we can create our model here. Okay, so the first thing that we can do is to set the clock first. Okay, so how to set the clock? We can come here, okay, and double click this thing, and we will get the clock properties. So here you can set whether you want to measure your model in seconds, minutes, or hours, or even days. Okay, and then you can also set the days per week that you would like to simulate. Okay, for example, you want to set 5 working days a week, or you can also set as 7 working days per week. Okay, so let's just set 5. Okay, and then you can set the running time. Okay, when the simulation will start. Okay, here the default time is at 9 o'clock, and then we have the duration of day, which is at 8 hours, okay, of the working time of the day. We can also set the warm-up period here, okay, and it is in minutes, warm-up period. And we can take the result collection periods, okay, how long we are going to measure our simulation. Okay, so this one, the simulation will be running for 1 week. Okay. Okay, so that is how we do the clock setting. Okay, you can also set if you like to have a digital face here. Here we have the clock face. Okay, just set it at the as the standard. Okay, next, let me introduce you to the object. Okay, the fundamental object that we must have in our simulate model. The first thing is to have the starting point. Okay, we can just click and drag, or we can just click here and click, okay, in the page here, and it will appear. Right. So this is what we call as the work entry point. Okay. So this work entry point is very important for us because we can, this is where our work item will enter our simulation. Okay. And then you will ask me, what is a work item? Okay. So work item, it is not here, right? It is not here, but it will come through this work entry point. Okay. So work item here is actually the item that moves through the simulation model. For example, it will represent the identity to be processed, okay, in our model. For example, if we have a call center, okay, the calls that come in is actually the work item in our simulation. Okay, so if we have a patient in a clinic, okay, patient can be our work item, okay, in our simulation. Okay, so this work entry point, if we double click this, we can see the properties. Okay, we can change the name here. Okay, and then this is where we set the work item type. Okay. If we have more than one work item, we can set it here. Okay. And then we also have the inter-arrival time, okay, where we can specify based on a certain distribution here. Okay. We can have the exponential distribution and other distribution here. Okay. And the good thing is we can also create our own distribution. Okay, so this is first at start time. Whenever we tick this box here, okay, we will ensure that an arrival is generated at time 0 regardless of the distribution we use. Okay, so subsequent arrivals will be random and follow the given distribution here. Okay, when we tick the unlimited arrival here, okay, then automatically our start point will become a passive, it will become a passive work center. Okay, where it will no longer push the item into the system. However, it will depend on the work center that itself. Okay, we will have the next, we will have the work center. So it will refer to the work center where this work center will pull the work item, okay, from the starting point here, okay, from the work entry point. Okay, file here that we have, okay, if we look at this, okay, it means that we can use the CSV file, the Excel file, if we have multiple work item. Okay, so this work item, multiple work item, we can use label. okay, to differentiate the type of work item that we have. So this label we can put into the file. Okay, I'm not going to explain all of the meanings here. It will take some time. Only the important ones. Result. Okay, so in the work entry point, these are the results that we can see. Okay, the number of work item entered the entry point, the number of work item lost, and the number of work item remain in simulation. Okay. So if we want to see the result in the summary, we can just right click any value here, okay, and it will be entered into the result summary. All right. Next, we have batching. Okay, batching here means that if we want to set our work item to enter the system in batch, okay, we can set the amount of a batch that we want to set. Next, we have the routing out. Okay. The routing out is where the work entry point here will assign our work item, okay, into the work center according to the certain discipline of our rules. And then we have the action. This action is the label that we want to assign to our work item. Okay, for example, if we are going to simulate a factory producing 3 different blouses or shirts, okay, so we can put the label for these shirts. For example, the label is based on the color or the size or the types of shirts that we have. Okay, so we can use label to differentiate the work item, okay, coming through this work entry point. All right, graphic is just about changing the graphic of our objects. Okay. This is the carbon footprint. Okay. Okay. Next, from the work item here, we can start with the queue. Okay. So the queue here means that it is a storage bins. It's a storage bins where work item can queue here or can be stored here before it can be processed by the work center. Okay, for example, it can be a waiting room for the patient before meeting the doctor. Okay, or if we have a call center, it can be a call put on hold. Okay, before it can be served by the people there. Okay, so we have the storage here. If we look at the properties, there is a capacity of the storage. There is also the shelf life, okay, of the storage, and this is we can use this if we want to model for a perishable item. Here we can set the minimum waiting time, okay, and prioritize last in first out, okay, segregate result. This we can use if we put label for our work item. Okay. Again, we can also see the results here, okay, and we can choose which results that we want to include in the summary. If I take this one, the number of item, the storage, I can take the average, okay, and the maximum and the total and the storage. I can also record the queuing time, the average queuing time in the storage. Okay. Next, we can have, after having the storage, we can have the activity here. This is the work center. Okay, so this work center is where our work item will be processed. Okay. If we double click the work item, the work center, these are the properties, okay, that we can set. So we can set the name of our work center. Okay, we can set the processing time, okay, for our work center here. Again, we can also use distribution that we have here, or if the distribution that we have is not listed here, we can also create a new distribution. Okay. Next, we have the results, where in this result we can have the total number of items entering the work center. Then we have the completed job. Also, we can have the working percentage of our work center, and what else? Awaiting work. We can just select any result that we would like to see. Okay, so in the work center here, we can have the routing in. Okay. So these are the disciplines that we can choose for our routing. Okay. And we also have the route out here. We can use that if we have label. Okay, the label is here. Okay, for the actions. And we can set the priority for our work center. For example, is it based on the label? Okay, or we want to put a fixed value for our work item. Replicate. Okay, replicate here means that we can copy the work center, okay, based on the number. If the function is the same, then we can just do the replication of our work center. Okay. And lastly, we can add the work exit point. Okay, so this is where our work item will leave the simulation model that we have here. And launch this. Okay. So this is a must. Okay, we must include this because this is where it will record the statistic of our work item. So it's aggregate result if we have label of different items, okay, and the results we can choose the number of completed items, okay, the time in the system, the minimum time in the system, the average time in the system, and the maximum time in the system. Okay, so that is time in system within limit. Okay. We set the limit in the system, okay, and then we can see the percentage of the work item with the limit. We can also include this in our result. Okay. So let's try and run the item here. Okay, we can have the speed. Okay, if you want to see how the work item move, we can slow down the speed here. Oh, this is very fast. Okay. You can also slow down the speed if you want to see the movement of our work item. Okay. If you want to make it fast, you just slide this button to the end. Okay, so after we run, it will finish at 5 p.m. on Friday because we set for 1 week. And then we can see the result manager. So these are the summary, okay, of our result, the one that we select earlier. Okay, we can see the number entered. We can also see the number completed, meaning that we still have 4 4 items in the system. Okay. All right. So another object that we must consider in our model is resource. Okay, so the one that I showed you earlier is the basic object. Okay, now I would like to add the resource. Okay, so this resource must be attached to the activity here. Okay, because resource here is actually a special object that may be required by a work center in order to operate. Okay, for example, if the work center here is for surgery, then the resource can be the doctor. Okay, or the resource can be the nurse. Okay, or if this is a desk, okay, so the resource here can be the receptionist sitting at the desk, okay, to process a call. Or if we have a machine here, okay, the resource can be the person or the worker who operates on the machine. Okay. So if we look at the property of the research here, the resource here, okay, you can rename the resource accordingly. And then you can put the number of this resource here. For example, you can set this as 3, okay, 3 resources. And then you can add the shift of the resource. Okay. So this is the shift work pattern. And then we don't have the shift. Or we can add the schedule sheet. And the resource scheduler can add and the pool of resource. We can also have the result, okay, the utilization of the resource, okay, the traveling percentage of our resource, and the average utilization of the resource. Then we have the travel times. We can set the travel time from one activity to another. And then can have the priority matrix of our resource. Okay. All right. So once we have the resource, it is very important that we add the resource at the work center. Now the work center do not have any resource yet. Okay, so how to add? We can just click the properties of the work center, click resources here, and then just add the resource. Since we only have one resource here, we can just add this one. Okay, and then there are some settings, okay, for the resource. I just use the default setting. So these are the details of the setting for our resource. Okay, so if we run this one again, so we can look at the result manager and see that there is already the resource here, okay, in our result summary, and the percentage of utilization of our resource is given here. And since the resource is just stay at only one work center, so there is no traveling percentage involved. Okay, so basically that is the introduction to the resource, to the object that we have in our simulate.
Okay, so I hope you
understand the explanation on Simul 8 just now? Yeah, that one is on getting started on Simul 8. Now let's look at on the example to build the simulate model. Okay, so this one is very short, but I will show you how to use the label and how to set a certain routing out for our problem.
Our next example will show how we are going to sort three colors based on labels and using the routing out function in Simulate. All right, so let's start with the work entry point. Then we add the Q here. After the Q, we add the activity. And after activity, we add three different Qs so that we want to see the Q where they sort the balls. Okay. Yeah. Okay, so we can rename the, let's enter here, okay, as the ball sorter. And this one we can rename as QA. QB. Okay, here we have to add label so that every time work item comes into our work entry point here, it will put label 1, 2 or 3 to our work item. Okay, so let's add a label here. Okay, so this label we put, I'm going to use an image, so that's why I have to put image here to refer to image folder. And then I will have the name of my image is ball. So that will be my label. Since I'm going to set only 3 colors, I will put the label value using distribution rounded uniform with lower bound 1 up to 3. Okay, that is the label assigned to the work item here once it enter. Okay, so now I have to make sure that I have the image of balls in my image library. Okay, so I'll go to view, select image library, and then when I check here, I have no image with the name of ball. So I have to add the library. Okay, one. Okay, so ball 1 here we refer to the label number 1. Ball 2 for label number 2. And ball 3 will refer to number 3. Okay. So next, I have to sort the ball according to the queue here. So when I check the properties of the ball sorter activity and our routing, okay, out for this activity, I can select for the label. Okay, I select the label that I want to sort. And this label, number 1 will go to QA, label number 2 go to QB, label number 3 will go to QC. Okay, if I want to change that, I can move. Okay, where label number 2 will go to QA. Okay, so I can change that. Let's not change this yet. Okay, nothing else I would like to change here. Okay. So if we try and run this model, let's reset and run. Okay. So the speed here is the average speed. You can see that the gray bar will go into this queue, green will go to this queue, okay, and red will go to a queue here. Okay. However, if you want to see this clearly, you can also set this. First, you can set this so that you want to display the queue, okay, like this. So you want to display the queue here. And also, you can also set the graphic. For this one, you want to see the work item. Okay, or if you want to set the number of work item going through this support center, also can. Okay, you want to put the image, also can. If you don't put the image, no image. Okay. And, if you want to put invisible, it can be invisible like this. Okay. All right. So that one is for the work center. Now for the queue here, we can also display the queue if you like. Okay, but I do not want to put the queue. But for here, I would like to put the label so that I can see which label is coming through this work, this queue. Okay. Here, I cannot put the label, no label here. But here in the queue here, I can put the count. I can also put the label for each ball here. So it's going to be full with the label. So I do not want to remove. So the count, so the count. Next for the view, I can put the title so that I can see the title of each object that I have here. Okay, so let's reset and try to run again. We can speed it up. So we have here up to 6 balls so far, 13, 15 here. Okay. So we can see that all the balls are sorted according to the colors. Okay, once we have the label. So that's how we use the label to do the sorting as well as the routing out function.
Okay. So, okay, before we go to the conclusion, basically that is the basic of Simulate that I can show you. Okay. But actually, there are many more functions in Simulate that you can see. For example, we have the visual logic. That one is the advanced level, where you can put the logic in your model. Okay, if you have this, then it will go there. Otherwise, it will go here. So you can do the setting as well in your Simulate. Other than that, you can also have the I already mentioned, you can also set your own distribution or combine a certain distribution for a certain label. Okay, so there are many things that you can do with your Simulate actually. All right. So as a conclusion here, I would say that Simulate is a very great tool a decision maker can make. Okay, because it is very cost effective with a rapid development environment. You can see that how easy we can create a certain simulation model. Okay, but the only problem is before we begin on the simulation model, we must first must know the process, okay, of simulation, where you have to understand the system very well and come up with the data, okay, needed before we can proceed with our model. Okay, and I would say that Simulate is also suitable for beginner in discrete event simulation. All right, so these are the useful link that you can go to see the simulation. Okay, so there is the simulators comparison. You can see many types of simulator software we can see. And this one is, I think this is the manual, okay, to use the Simulate. Okay, so that's all from me. The showcase on Simulate. If you have any question, feel free to message or share your question here.
Okay, thank you, Dr. Arina. This seems a very interesting and useful software. So now we open the Q&A sections to the floor. So is there any questions from the floor? You can put your question in the chat board and on your ask questions.
Okay.
Okay, there's a question. So, yeah, so the question is about, hi Dr. Arina, we add other policies such as FIFO in the Q property.
Oh, okay. FIFO is the default setting in the queue in Simulate. Okay, so that's why if you look at the model just now in the queue property, we can see that we have LIFO, okay, last in, first out, because otherwise, if you do not want to use the FIFO, then you can set for LIFO lah. But FIFO is the default one lah.
Okay, so So Dr. Arina have answered the first question. So is there any other questions from the floor? And host, can you check, is there any question?
How much to Simulate? Last time when I purchase, when I request our CICT to purchase Simulate, they display the price at that time. But now if I check the website, it is no longer displayed there. So we have to personally email them and ask for the price. Last time, the cost is about 2,500 ringgit Malaysia. So just one time purchase. With, I think it's unlimited number of students can use, but only limited to 3 months only.
Okay, so thanks for the answer. So any questions from the participants today about this software? Okay, so it seems like no any other questions. So here I'd like to end the session. So again, on behalf of iADORE2020, we'd like to thank. Okay, oh sorry. So I saw another question. Okay, so there's another question, Dr. Arina. Yeah. Any other
alternative software? Yes, there are many. There are many. We have process model, we have AnyLogic, Pro Model, Arena, FlexSim. There are so many software on simulation. Okay, but I never explore. I only have used Simulate before. Okay, but you can try and explore. So far, Arena is one of the famous one that I see many people are using Arena. Okay.
So is the Arena free software or we need to purchase it?
Everything we have to purchase. But wait. You have to go to the website. Let me share the photos here. Let me share my screen. Wait, Where is it? All right. So this is the software that I managed. There are many more actually that you can go. Okay. So I already give my link here to see the simulation comparison if you like. Okay. And this software actually some of it as I browsed through before, some of it also provide the free trial. Okay, if you would like to try first, but with certain limitation lah. Okay, but I don't remember which software, but you can always go and survey, okay, online in their website. These are among the software that they offer. I hope that answers your question, Dr. Hasina. This one also put the price here.
Okay, so thank you so much for the information. Also the pricing. Okay. Okay, so yeah. So is there any other questions? Yeah, last questions?
Yes, thank you. Welcome, Prayom Saha. I hope this information is beneficial to you all. Okay, maybe you can explore the simulation area after this.
Yeah. So yeah, I think so everyone have learned a new thing for you today. So again, so on behalf of IADORE 2020 committee, we would like to thank our speaker today and also your participation in this showcase. So please stay with us in IADORE 2020 and I hope to see you again in the next sections 2:30 p.m. So now I would like to pass the session back to the host.
Yes, thank you very much, Dr. Hang. And once again, thank you very much to our speaker, Dr. Nur Arina Bazila Aziz. Next, we are going to move to our break. Our break will commence right after this. But before that, to UTM students, once again, please do not forget to scan the QR code, which I will be displaying here. So as you can see, this is the QR code. Please scan this QR code via your UTM Smart application and make sure you register for this session. For the next session, we will continue our next session at 2:30 p.m. With an ISM session.
Welcome to iADORE 2020 special session supported by Institute of Statistics Malaysia. I am Arifah Baha from Universiti Teknologi Malaysia, Center for Industrial and Applied Mathematics. Also an EXCO member of Institute of Statistics Malaysia will be the moderator of this session. This special session is run in conjunction with iADORE 2020 to promote Institute of Statistics Malaysia experts and as part of its reach out activities. We have with us today 3 speakers. Each will be given 15 minutes to present their work in the area of statistical sciences and operational research. There are 3 of them, but I will introduce our first speaker first. Our first speaker is Prof. Hafsah Midi. She has been elected to the post of ISM Vice President since 2014. Prof. Hafsah Midi is a professor of statistics at Universiti Putra Malaysia. She has published more than 150 index papers and her research areas are regression diagnostics, robust statistics, quality control, and experimental design. She has supervised more than 30 PhD and master students. Today, she will present her research work entitled The Correct Technique to Rectify Multi-Collinearity Problems Caused by High Leverage Collinearity Enhancing Observation. Without further ado, please welcome Prof. Hafsah for this talk. Over to you, Prof. Hafsah.
Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon to all. First of all, I would like to thank the organizing committee who has invited me for this presentation. But I think I'm quite nervous because I was given only 15 minutes. I'm not sure how I can finish in 15 minutes. Well, this is the topic of my talk with my PhD student regarding multi-cognitive. It is a common, multi-cognitive is a common problem in statistics. But what is not common is multi-cognitive caused by high leverage cognitive in enhancing observation. So this is the outline of my presentation. And well, this is for the linear regression, where there are many assumptions for this regression model, but one of those are there's no multi-cognitive in the model. And multi-cognitive, as we know, there are a situation when two or more independent variables are highly correlated. So it will result in wrong sign problem, produce large standard errors of regression. And since multi-cognitive is this is a problem in the data, there is no statistical test for its presence. But diagnostic method can be used to detect the existence of multi-cognitive. And one of the commonly used diagnostic method is the variance inflation factor, where if the variance inflation factor less than 5 indicate no multi-cognitive, between 5 and 10 shows moderate, and higher than 10 shows severe multi-cognitive. So in statistical data analysis, I just want to highlight here, there's only one type of outlier, but in regression, because this is related to multi-cognitive, I have to explain what is this first. In regression and regression, there is several types of outliers. There is the residual outliers. These are the residual outliers, observation with large residual. This is here, this observation here is outlying observation in the X direction, where I call this high leverage point. And this is what observation, outlying in the Y direction, we call it vertical outliers. And this is not common. It is now evident that high leverage point, which fall far from the majority of the explanatory variable, can induce or disrupt multi-cognitive pattern in the data. Observation responsible for this, we call it high leverage cognitive influential observation. This high leverage point that induce multi-cognitive, we refer them as high leverage cognitive enhancing observation, while those that reduce multi-cognitive in their presence are called high leverage reducing observation. So in this presentation, I just want to focus on high leverage cognitive enhancing observation. Well, in the presence of high leverage cognitive influential observation, the classical variance inflation factor failed to correctly detect multi-cognitive problem. So the CVIF wrongly indicate multi-cognitive in the case of having large variance inflation factor in the situation for high level cognitive enhancing observation. So here, if we rely on the CVIF, we will get misleading conclusion. So then we will use incorrect remedial measure. Well, this I think I don't have. So the objective of this presentation is to show that high-level cognitive influential observation can change multi-cognitive pattern of a data, whether it is high-level cognitive enhancing or reducing observation. And we want to show that the classical VIF is not reliable. It's not a reliable diagnostic measure to detect multi-cognitive in the presence of high-level cognitive influential observation. And we want to propose the correct estimation method to remedy the problem of high leverage cognitive enhancing observation. Before I want to discuss how to remedy the problem of high leverage cognitive enhancing observation, first we have to know how to detect high leverage cognitive influential observation. Because given a data set, you must know whether you want to, how you want to know whether the multi-cognitive in a data set caused by high leverage cognitive enhancing observation. So first, well, to do this, to develop this method, there are 3 steps. We develop this method by using 3 steps. In the first step, you have a data set. In the first step, what you do, first you have to suspect the high leverage point in the data set. You suspect first. How do you suspect this? You use robust Mahan-Robis distance. So these are the robust Mahara resistance where the TR here is the location vector, CR is the covariant matrix. Yeah. But the commonly used location vector is by using the classical way how to estimate them using the classical way, the least square method. But those method is not robust, yeah, easily affected by high leverage point. So what we do here, we try to use the some of the commonly used robust method is by using minimum volume ellipsoid or minimum covariant determinant. But those estimate takes very long time. Yeah. So what we do here, we make use of another way how to estimate the T and the CR, yeah, robustly and very fast. Yeah. So in this situation, we will make use of the index set equality. But this takes long time to explain. Just want to mention that we make use of the index set equality to compute the location and the covariant matrix. Yeah. Then that is the first step. Yeah? You try to suspect the high leverage point. Then the second step, once you suspect, okay, you use the robust Mahara resistance, you suspect the high leverage point. We put it into deletion set. Yeah, the good observation, we put it in the remaining set. So after we suspect the high leverage point, we want to confirm this by using the potential. We develop this potential where if the observation detected as high leverage point, we equal to this. If it is good observation, equal to that. Yeah. So now we get the values of PII to confirm that those high leverage point is really high leverage point. Yeah. So that the second step. Then the third step, the third step, because you know already the confirmed high leverage point and the good observation. So you develop this. This is the high leverage quantity influential observation. Yeah. So if is the number of deletion set not equal to 1, meaning that more than 1, so we make use of this. If it is equal to 1, we make use of this. If it is in the remaining observation, we make use of this equation. Yeah. So then we can test our data whether there is high leverage quantity enhancing observation, or reducing observation. So we make use of this well-known Hawking-Radu-Cas data. Yeah. We make use of this data set. Yeah. Where this data set has 75 observation, where there is a 14. The first 14 observation is high leverage point. Yeah. And cases 1 to 10 bad high leverage point. And 11 to 14 is known to be good high leverage point. A good high leverage point meaning that it doesn't affect the parameter estimate doesn't affect the parameter estimate of the estimator. Yeah. So by using our this is Ali-Hadi measure. Yeah. This is the Sengupta measure. Yeah. Cannot detect. Can detect a few high level quantity influential observation. But for our method here, our measure here can detect the first 14 observation as high level quantity enhancing observation. Yeah. So this seems that our method is good because I don't put it. This is just an example. Actually, we have more than that. Yeah. Okay. Then if this is the variance inflation factor. I think everyone very familiar with this formula. The classical variance inflation factor. Now we want to see. Yeah, because I already show that by using our diagnostic method, we show that the first 14 observation is the high leverage quantity influential observation. Yeah, is it enhancing observation? Enhancing observation meaning that in the presence of when there's no high leverage point, there's no multi-quantity problem. But in their presence, the data become multi-quantity. So this is what we call high leverage quantity enhancing observation. So now you look at this. Look at our data just now. We have 14 observations. Using our method, we detect the first 14 observation as high leverage quantity influential observation. Yeah. So now look. Yeah. So if original data with 14 high leverage influential observation. Now, if I remove the first 14, look what happened. This one in the, well, you may use Bayesian correlation as well to detect multi-correlate. So VIF greater than 5, meaning that there's a multi-correlate problem, and you may also use condition index greater than 10 shows multi-correlate problem. Now, look. Now, if you look at, let's say we look at one of these, give the similar result. Original data have a high level quantity influential observation. I have shown already. Now, if I remove that, we remove the first 14 observation. What happened? Look, the value becomes small. Small value of VIF indicate there's no multi-correlate. No high leverage point, no multi-correlate. But when there's high leverage point in the data, there's a high leverage, original have high leverage, shows multi-correlate because value is greater than 10. So this is what we call high leverage quality influential enhancing observation. Well, so I think I don't have much time to show all those things, almost time. Okay, so well, another one here I want to show you. Okay, we generate, we use artificial data. We generate a data with no polarity. So see the VIF very small, or less than 5. And this is where is the classical VIF, all small. If this is all our method here, we develop some method, robust variance inflation factor. In original data has no multi-correlative, we generate non-correlated data. So we see all small. Now, then we purposely contaminate the data by having some high leverage point. Look what happened now. Look, see VIF, the classical before, very small. Now when I contaminate the data, the classical become large here. Because the multi-correlate, if the maximum values of VIF greater than 10, we show serious multi-correlate. So in the presence of high leverage point, we can see that. The classical VIF show that there's a multi-correlate. This is what we call high leverage quantity influential, enhancing observation. So here I just want to highlight to the audience that not many people aware of this, because if you have a data set, then the first thing you need to do, you need to detect whether your data has high leverage point or not, whether it has high leverage quantity enhancing or not. So if you don't do all those things, you just rely on the classical VIF, you think that, oh, there's a multi-correlate in the data set. So then you said that if there's a multi-correlate, I will make use of latent root regression, ridge regression, and many other regression techniques to remedy the problem. But when the problem is due or caused by high level quality enhancing observation, is not efficient enough to make use of those latent root or ridge regression to remedy the problem. So what you need to do is to make use of robust method to remedy this problem. So well, there are many robust methods to estimate the parameter of the model. But all those methods, MMM, LMS, LTS, and so on, they do not have the three properties: high breakdown point, high efficiency, and bounded influence property. So it has been shown that GM estimator has these three properties. So we make use of this GM estimator. But the commonly used GM estimator, this is the GM estimator, make use of this formula and elaborate. So this GM estimator that commonly used, introduced by Cooley and Hetzman-Berger, this estimator has some problem. Because the initial weight that is used here based on the robust Mahalanobis distance. Robust Mahalanobis distance are based on the minimum volume ellipsoid or minimum covariance determinant, which has three weaknesses. Number one, it takes very long time. Yeah. Number two, yeah, when you detect a high leverage point, you do not, you do not classify whether it's good or bad observation or bad high leverage point. Yeah. So it is very important to mention that good leverage point shouldn't be downweighted, yeah, because good leverage point will contribute to the efficiency of the data. Yeah. So in this situation, yeah, we try to, because of this weakness, we try to develop a method, yeah, that only downweight those high leverage point which is bad high leverage point only. Yeah. So then, yeah, well, this is the method. I think Dr. Arifah, how many more minutes to go? I think I don't have time to mention about that. Yeah. So our method now, yeah, what we do now, we try to make use of very fast technique to estimate the location and the covariance metric by using index set equality. Yeah. And also try to downgrade only the bad leverage point, yeah, not the good one, because I already mentioned good leverage point contribute to the efficiency of the data. Yeah. So then we develop some method here. I don't show that. Finally, using our method here, once you get the data, then you know that you can classify your data, whether your data have vertical outliers, bad leverage point, good, and so on. You can use our method to classify them here. Yeah. Then okay, well, yeah, then that is the estimator, the GM estimator based on our method. Yeah. So we make use of I think no. So I just want to do we do some simulation study to show that our method has high efficiency. Yeah. So let's look at this. We generate a data set where there is no multi-quantity. So I mean the X, how many observation? We have 3 independent variable, yeah, sample size 20 and so on, and then we compute the VIF. VIF all very small, indicate there is no multi-quantity problem in this data. This data is clean, no multi-quantity. Yeah. And then we make, well, yeah, because if you see that, you may use ridge regression and you may use latent root regression and many other ways to estimate the parameter. And here I show you this is our method here, yeah? And it shows that all the methods are equally good, yeah? Because there's a good data set and no collinearity. Yeah? So you look at all the efficiency of the data is quite good, quite close. No multi-quantity, very clean data. Yeah. But now let's look what happened. What happened now when I contaminate the data? I contaminate the data to have high leverage point. Yeah. So when I contaminate the data, yeah, well, this coefficient doesn't appear here. Look, the VIF become large. I use you look here, the value of VIF become large. When VIF become large, it shows that there is a multi-quantity. Yeah? There is a high leverage quantity enhancing observation. Yeah. So look what happened now. Yeah. If I look at the efficiency of the estimator here. Yeah. If look at our method here, the efficiency is still high, even though there is a high leverage point here. But if you look at the OLS, ridge regression, and any other method, yeah, the efficiency is less than our developed method. Yeah. Now, so now I want to apply. Yeah, give me 5 minutes, yeah, Dr. Arifah. Yeah. Now let me apply this our method to the aircraft data set. Yeah, to the aircraft data set, where there are, for this data set taken from Gray and have 23 cases before predictor variable. And then once I get the data, I want to know whether my data has high leverage point, good leverage point, vertical average, and so on. Now, if you make use of the classical method, you only get 22 vertical outliers, and this is this is good leverage point. Yes, this is all classical method. Look, this is our method that classify observation 19 and 22 is the bad leverage point. This is good leverage point. This is the vertical outlier. Yeah. So I mean, we already shown that our method successfully classified the observation into proper class. Yeah. Then we try to estimate the parameter of the data. I mean of the model. Yeah. So now we make use of OLS, MM, GMC, and so on. Yeah. We can see that we make use of the standard error to make the comparison, to evaluate their performance. And it seems that our method here shows the smaller standard error compared to the rest. Yeah. And it is our method here with numerical example as well as with the simulation shows that this method is more efficient than the existing method. Yeah. And for the conclusion, so we have shown, well, here I have to highlight the classical BF wrongly diagnosed multi-chromity and suggest incorrect remedial measure. If you use classical BF, you will use incorrect remedial measure because you thought that this high leverage point, you do not know about this high leverage point, high leverage quantity enhancing observation. Then you make use of other remedial measure like ridge regression, lateral regression, and so on. Yeah? So for high leverage quantity enhancing observation, we suggest using our method here to avoid incorrect interpretation, incorrect remedial measure, and misleading conclusion. Yeah, that's all, Dr. Arifah. I think is it more than 15 minutes? I am not sure, but I am not satisfied with that. I cannot speak more. Yeah.
Prof. Hafsa, I know that you need more time, but we need to give a chance to.
Yeah, I understand.
Yeah, but all participants, please, if you have any question, write it in chat box and we will read it later. Yeah. For our second speaker, Dr. Siti Suzlin. Doctor, you can share your presentation while I'm reading by you. Our next presenter is Dr. Siti Suzlin Supadi. She is a senior lecturer at the Institute of Mathematical Sciences, University of Malaya. She holds a BSc in Pure Mathematics from University of Malaya and her master and PhD in Applied Mathematics from the same university. Her specialization is on operational research and inventory modeling, vendor buyer coordination, and consignment policy. She has published many publications on OR, operational research, and supervises many postgraduate students. Her talk today, 2 warehouse inventory modeling for deteriorating items. Over to you, Dr. Siti Suzlin.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Okay, so I'm Dr. Siti Suzlin Supadi from Institute of Mathematical Sciences, University of Malaya. Okay, so today I will be presenting the paper entitled 2 warehouses inventory model for deteriorating items. Okay, roughly I will give a talk about a mathematical modeling in inventory problem which consider the deterioration under 2 different policies that are LIFO and FIFO. So before we go further, let's look at the definition of some of the important keywords in the title. Okay, so the first keyword is inventory. Okay, sometimes we call it as stock. Okay, stock, in general terms, in stock or inventory can be defined as physical stock of goods kept in store to meet future demand. So it also means usable but either resources that have economic values in material management. So it is important to keep inventory in the system in order to meet future demand and avoid shortage. Hence, it is important to the manufacturer or producer to produce the right amount and at the right time because there is a limitation at the warehouse capacity. Okay, so same goes to the distributor or buyer. They need to determine the correct amount to be ordered and when to order from the producer. So this is because too many stock or inventory on hand will lead to high total cost, but if it is too low, shortage may be occurred. Okay, so the second keywords here is warehouse. So warehouse is a place to store or allocate raw materials or manufactured goods. So manufacturer will store their inventory in their own warehouse. So it can be more than one warehouse. So in this research, we just consider one own warehouse with limited capacity and the other one will be rented warehouse. Okay, so the rented warehouse is to store the imperfect item that need to be reworked.
Because are you still showing your first slide?
Yes. Sorry, this is just two keywords. Sorry, I will finish in 15 minutes, inshallah. Sorry. Okay, so because in the production it may has defective items, so we assume that all the defective item will be sent to the rented warehouse. So this is the two important keywords, that is inventory and warehouse. Okay, so next is the contents or outline of this presentation. Okay. All right, so most classical inventory model consider the assumption where the available storage facility has an unlimited capacity. Okay, so but in reality, the storage has limited capacity, and an additional storage capacity known as rented warehouse is needed to store excessive inventory. So in this research, we propose two warehouse inventory model, which consider LIFO and FIFO. And so the aim of our research here is to develop a mathematical model which consider the LIFO and FIFO. And then the objective is to determine the optimal values of the period time in cycle of stage that will minimize the total relevant cost. Okay, so this is the literature review. Okay, so research regarding two warehouse inventory model has been carried out by various authors in the recent years. So it was first introduced by the Hartley in 1976. So he proposed a basic model of two warehouse inventory modeling. So in 1997, Agrawal and Banerjee considered the existence of the deteriorating items, okay, here, and provided option in choosing either one or two warehouses. Okay, so they conclude that the decision on whether to use a single or two warehouses is dependent on the relative values of the shortage cost. Okay, and then in 2000, Pakala Archery, okay, here, was first introduced the LIFO and FIFO. So it is generally assumed that the rented warehouse offers better preserving facility than the own warehouse. Therefore, it charges a higher holding cost. Okay. So then Lee modified Pakala and Archery model and proposed the FIFO policy. Okay. So in this model, he assumed that inventory in own warehouse, which is stored first, will be consumed before the rented warehouse. After that, in 2012, we and Will Diana, okay, considered the LIFO policy for deteriorating item and rework process. So he concluded that the rework process can reduce the cost involved in the production process. And then they extend the same assumption to the FIFO policy. So both of their model here considered a constant demand rate. Okay, and all these, all this research only consider the constant demand rate. Okay, so therefore our research problem here, okay, so here we will consider the increasing or decreasing this time, because the demand actually in the real life it is not constant. Okay, so we will consider the both LIFO and FIFO policy under varied demand. Okay, so this is the objective. We will develop a mathematical model under these two policy, LIFO and FIFO, and determine the optimal values of the time period, which will minimize the total relevant cost. Okay, these are all the location and the assumptions. Lead time is 0 and the replenishment rate is finite. Okay, the production rate P must be larger than the demand rate. So this is to make sure that no shortage will be occurred. Okay, only perfect items are stored in own warehouse, okay, while all defective items are sent to rented warehouse to be reworked. Okay, so the rework process is assumed to be perfect since special care is given to the process. Hence, all rework items are perfect. So the total rework item should be equal to the total defective item. Okay, so the production and rework rates P and R are assumed to be different. And normally P must be greater than the rework rates. Okay, the production rate must be greater than the rework rate. So the rented warehouse is located, we assume that rented warehouse is located near the own warehouse, hence the transportation cost between the warehouses is negligible. Okay, so this is the illustration of the LIFO policy, LIFO model. Okay, so the graph under W level is the represent the own warehouse. Okay, the inventory level in the own warehouse, and above W represent the inventory level in the rented warehouse. Okay, so the interval T0, T1 represent the production uptime. Here is the production uptime in own warehouse. Okay, so in this period, the perfect item is subjected to deterioration. Okay, so here, the perfect item here will use to fulfill the demand in this period. Okay, while the defective item will be sent to the rented warehouse here. Okay, so that's why here we have production rate, effective rate, demand rate, and the deterioration rate here. So after separated the defective item, then we will send to the own warehouse to be reworked here. Okay, so that's why here is RR is the rework rate, and then demand rate and the deterioration rate. Okay, so in the interval T1, T2 represent the rework uptime in the rented warehouse. All the defective items sent by own warehouse will be reworked here. So here the rework process is assumed to be free of flaws. So all the rework items are assumed to be perfect, okay, and as good as new. So the total defective items is assumed to be equal to the total rework items. Okay, and then T2, T3, okay, represent the rework downtime. Here is the rework process. So this is the rework downtime. Okay, so the inventory level in this interval decreases due to duration. Okay, and satisfying the demand. Okay, and at T3 here, inventory level becomes 0 because all the items have been consumed completely. So we will use all the finished product from the rented warehouse first. That's why we call it as LIFO. Last in means that first they comes they in at the own warehouse, and then second in the rented warehouse. So in the rented warehouse is the last in. So here last in and then first out. So they finish here T3 here. Okay, so in T1 until T3, okay, so T1 until T3, the inventory level of items stored in own warehouse decreases here, decreases due to deterioration only. So all the demand will be satisfied from the rented warehouse. Okay, so and lastly is the T3T. Okay, so this is represent the downtime period in own warehouse. So after 0 level for the rented warehouse here, so all the demand will be satisfied from the own warehouse starting from here. Okay, so here finished item will enter the own warehouse first since they are produced in the own warehouse, right? So after T1, all collected defective items are sent to the rework. Sent to the rented warehouse to be reworked here. So at the end of the production cycle, items are fully depleted in the rented warehouse first before all items are cleared in the own warehouse. So this phenomenon is known as last in first out. Okay, so then okay, so after that we need to find all the equation for I1 until I5. So we just solve the what we call it initial value problem here. Okay, so this is the same equation here. So we just solve the initial value problem to get all the equation for I1 until I5, and then we need to find the area under this graph. Okay, so we have A1 until A5 here. So because here AI represent the total inventory hold at each of the interval. Okay, so then okay, so here, okay, so we just substitute all the A1 until A5 here to get the total holding cost for the own warehouse and the rented warehouse. Okay, so and also we need to find the deterioration total number of deteriorated items. Okay, and then just substitute here. Okay, where the total relevant costs, we have 3 variables here. Okay, T1, T3, and T. Okay, and the total relevant cost is the addition of the setup setup production costs and processing costs, okay, and then reward processing costs and the holding costs in both own warehouse and rented warehouse. Okay, so then we have this total relevant cost. Okay, so this is the illustration of the FIFO. How many minutes do we have? 5 minutes more. Okay, so this is the illustration of, sorry?
3 more minutes.
3 more minutes, okay. So this is the illustration of FIFO. So the difference of LIFO and FIFO is the perfect items. In LIFO will be used from rented warehouse before the own warehouse. Okay, while in FIFO it is used from the from the own warehouse first before the rented warehouse. Okay, that's why we call it FIFO. So we just use the same idea, find all the I1 until I6, and then find the area under the graph, and then we can get the total cost here. Okay, all right. So we use okay, because the total relevant cost is quite complex. Okay, here we have non-linear equation. So we use the optimization tools in Microsoft Excel, Solver, and also Mathematica to find the optimal solution. Okay, so and we found that both of them provide the same values. Okay, so here, Solver and Mathematica. Okay, and then this is the result. Okay, we use the same parameter values for both policies. So the optimal solution for LIFO is 3047 here. Okay, while for FIFO we have 3076, which is greater than the LIFO. Okay, as we expected. Okay, so here we just change the parameter values here, PR and so on here to see the behavior of the model. So we observe that changes in T1 here, okay, in T1 affect the number of total item produced and the effective item. Okay, while changes in the value of T here, okay, affect the total demand. Okay, affect the total demand in the system. So for example, if when P increases, T1 and T become shorter, so the item produced and the effective item become less. So the total cost also decreases here. Okay, so for FIFO, we get the same pattern for the sensitivity analysis as we get in LIFO. Okay. Okay, so the conclusion. So in general, the total relevant cost of LIFO is lower than the FIFO. Okay, so 3047, which is less than the FIFO. So we, based on the sensitivity analysis of both policy, we observe that changes in the value of T1 affect the number of total item produced and defective item, while changes in value of T affect the total demand of the system. That's why TC will be decreased. So note that in FIFO policy, items are depleted from own warehouse first, okay, followed by the item in rented warehouse. Hence, items are stored longer in rented warehouse, which in return will result in higher holding costs. So based on our optimal solution, we can see that the total relevant cost for the FIFO policy is higher than the LIFO. So we can conclude that given the same values parameter, the LIFO system has lower total relevant costs when making the assumption that rented warehouse holds a higher holding cost compared to the own warehouse. And the further research, we can consider the different iteration rates, because in this research we assume that it is equal. So it can be different, okay, in own warehouse and rented warehouse, in comparison of shortage and costs which fluctuate with time, may be also considered. Okay, so this is all the reference, and thank you.
Okay, thank you, Dr. Siti Suzlin.
Thank you.
Thank you for your valuable sharing, and I believe that during this time of pandemic, your knowledge is very important for them, right? So, okay, however, all the questions, let all the participants leave it in the chat box. And now we'll move to our last speaker, Dr. Siti Rohani Muhammad Noor. She is our young and promising senior lecturer at the Department of Mathematical Sciences, Universiti Teknologi Malaysia. She holds a Bachelor of Science Honours in Mathematics with specialization of actuarial science from University of Minnesota, Twin Cities, United States of America. her master and PhD in mathematics from Universiti Teknologi, Malaysia. She is currently active in her research of stochastic population model. Today, she will present her talk on multi-population mortality model to Malaysian mortality data. Over to you, Dr. Siti Rohani.
Okay, Assalamualaikum and good day to all the participants iADORE 2020. My name is Siti Rohani binti Muhammad Noor. I'm from the Department of Mathematical Science, Faculty of Science, UTM, and also a member of Institut Statistik Malaysia and Climate Change Research Group, UTM. Today, I will present multi-population mortality model to Malaysian mortality data. Okay, to get started, let's look at the statement made by the Tan Sri Lilanti, which stated that Malaysia is expected to be an aging nation by 2030. Being an aging nation indicates greater advances that Malaysia has achieved in terms of education, healthcare, economic level, as well as other services. However, even though living longer seems good, but what we are concerning now is on the unexpected increase in the life expectancy. This would cause longevity risk. Longevity risk, it refers to the risk of outliving your savings. Longevity issues arise as people enter retirement, generally with a fixed amount of money to fund their retirement years, but with no idea of how long they will live and therefore no idea of how long their money needs to last. Okay, before I proceed to the next slide, I want to show you some website from the Department of Statistics Malaysia. But first, let me close this. Let me stop sharing here first because I want to show the DOSM website. Here. Okay, can see right the DOSM website.
Yes, we can see.
Okay, so you can go to this website, Department of Statistics Malaysia. So we have this tab, Find with Statistics. You can actually estimate the life expectancy that you have. Okay, so you click here, the life expectancy system, and you can key in the date of your birth. Okay, so for example, 5/5/1980. Okay, and your ethnic is, for example, Bumi Putra, and your sex is female. Okay, so here your life expectancy is 37.7 years, which means you could live longer until 77.7 years. Okay, let me stop sharing this one first. Okay, so this is the expected life of your life expectancy. However, we are not sure whether we will die at the age of 77.7 years, right? We might die at maybe around 80 or around 90. What if we die at 80? However, the retirement incomes that we have, it could only last until 77.7 years. Okay, this would cause inadequate retirement income, and this is what the definition of longevity risk means. So that's why the topic of the multi-population mortality modeling is important, because we want to mitigate this kind of longevity risk. We don't want to outlive your savings. We want to enjoy our golden years. So that's why we need to know the importance of this topic in helping us to shape our retirement years. Okay, now I'm going to share my PowerPoint slide. Okay. Okay, now can see my slide?
Yes.
Okay, now let's continue to the next slide. So if we are not preparing to become an aging nation, it would cause several implications to the healthcare, financial, city planning, and also social service. And also some of the peoples, instead of they enjoy their golden years, they have to continue to work due to the inadequate retirement income. Therefore, to manage the longevity risk, individuals, governments, and fund providers, they should do some reassessment to their current policies in order to prepare for the aging nation. Such as individuals, they can do some significant changes to deal with longer term risks and longer term investment. Whereas for the government, policy changes in the areas of labor, health, pensions and retirements are necessary. While the fund providers, they should assess the framework of their product ranges for their current and future client. Okay, that one is for the part of individuals, government and fund providers. However, as a statistician, okay, as people who learn about statistics, what can we do to mitigate this kind of risk? Okay, so to mitigate the longevity risk, we could actually forecast the life expectancy accurately. So the one that I showed you just now in the Department of Statistics Malaysia, that one they use the average life table, which is in the form of periodic mortality table. They does not include the projection of the mortality rates. Okay, so that's why here in this study, we are going to include the projection of the mortality rates into the mortality table so that we could obtain more accurate forecast of the life expectancy. So in this study, there are two factors that we should consider while doing the multi-population mortality model. The first one is on the current mortality trend, while the second one is on the projection of the mortality risk. So the current mortality trend will be applied to the proposed multi-population mortality models. So we have two proposed multi-population mortality models here. So I'm going to explain more about this later in the next slide. And then the time series data that we obtain from the proposed model will be used to make a forecast on the life expectancy. Okay, so this is the Malaysian mortality data. So the Malaysian mortality data is highly dimensional. Not only Malaysian mortality data, all mortality data from other countries as well. Why it is high dimensional? Because it has more than the two variables. So we have here the variables gender, time, and the age group. So we are going to capture all these informations in order to make sure we can do accurate forecast life expectancy. Okay, so this is the plot of the Malaysian mortality data. So as you can see here, the pattern of the male race and the female race, they look almost the same. So that's why we believe that there is an independency between the male race and the female race. That's why we want to include this dependency into the multi-population mortality modeling. And also we are going to also look into the variance of the age and the years into the mortality modeling. So this is the proposed mortality models. So we have two proposed mortality models. The first one is augmented O'Hare and the second one is the augmented O'Hare in a state space framework. So what is the advantage of this proposed model as compared to the previous one? So before I explain about the proposed models, okay, so if we can see here, we have two kinds of the mortality models. The first one is on the single population mortality models and the second one is on the multi-population mortality models. The single population mortality model is limited by the fact that it does not include the dependency between population. Okay, the population can be in terms of gender or also can be in terms of country or races. However, since they do not incorporate the dependency between population, therefore the life expectancy that they produce is unreliable. While for the multi-population mortality models, they could capture the dependency between populations. However, they could not capture the full age variances across all mortality rates. Therefore, this would also cause inaccurate forecast of the life expectancy. To improve the existing mortality models, we extend the O'Hare and the Lilly mortality model into the augmented O'Hare mortality model. And then we extend the augmented O'Hare into a state space framework. So why we need to extend this mortality model into the state space framework? This is because this model, okay, the augmented O'Hare and all this model at the above row, they have redundant errors. Okay, that's why we need to integrate them into the state space framework in order to ensure only one error into the modeling. I will explain to you about this later. Okay. Okay, so here is the equation. Okay, the equation of the mortality models. So this is our proposed mortality models. So if we can see here, okay, this is actually Okay, the equation in black color is actually the regression linear models. Actually, here we have the error here. Okay, every regression models, we have the error here. Okay, so we have one error here, right? What does it mean with redundant errors? So what does it mean with redundant errors? So actually here from the mortality models, we have the time series index, which is the KT. So all this KT is actually the time series data. This KT will be used to forecast the life expectancy. Okay, so how to forecast the life expectancy by using this KT? So we are going to model this KT using another time series model. So that means here in KT, we have another error inside the KT. So if we have many KT, we would have many error in the KT. So that's what it means with the redundant error. Okay, we does not only have the error for at the regression model, we also have error at the time series model. So that's why we need to integrate this this independent estimation. We call this one as the independent estimation. Okay, that's why we need to integrate them into a unified estimation, into an estimation that has only one error, in order to minimize the error, in order to avoid the unreliable forecast of the life expectancy. Okay, so these are the results and the discussions of our proposed mortality modeling. So as we can see, the proposed mortality model has the lowest errors as compared to the others. Okay, and also it is a very important for us. Okay, this is where it comes the importance of checking the normality of the residual. It should be normal in order to provide accurate forecasting. Okay, so if we can see here, okay, this residual is non-equal, and also the residual is not near to zero. So that means the residual of the proposed models of the existing mortality models not normal. Okay. Okay, while for our proposed models, okay, it looks normal because it reaching to zero, have random pattern and have equal variances as compared to the previous models. This one is for male, while this one is for the heat map. The residual plots in terms of the heat map for male. So if we see these plots, okay, there is non-random pattern here and also strong clustering. Strong clustering means this one. The color is sometimes here we have two blue colors, two orange colors like that. So this shows that these models, they could not accurately capture the age pattern variances between mortality rates of male and female. So that's why we have the strong clustering pattern here. And whereby our proposed mortality models, it doesn't show any strong clustering. So we can see that the proposed mortality models is normal for their residual. Okay, while this one is for females, same like the male, we have random pattern and we does not have the strong clustering pattern for our proposed mortality models. Okay, and then after we have, after we did the current mortality modeling, the historical mortality modeling, then we do some outsample measurements error. We do the forecast measurement for the mortality rates, and we found that our proposed mortality modeling obtained the less measurement errors for the forecast measurement. Okay, and also, okay, next, the coherent ratio of the predicted mortality rates for male and female is expected. The coherent assumption is proposed based on the narrowing gap of sex differential on the mortality improvements. Therefore, it is expected that the projection of future mortality rates of male and female would be converging to the same value, in which eventually the ratio of the male to female should be constant as the time increases. So based on this figure, okay, the proposed mortality modeling achieved one of the main criteria in building the proper mortality modeling, which is to produce non-diverge mortality rates forecast in the long run for all age groups. Okay, So as overall, the proposed mortality models, which is the augmented O'Hare and augmented O'Hare state space, are found to be superior in terms of historical fit and predictive accuracy for male and female. More than that, the proposed model exhibit the criteria needed in selecting the best stochastic mortality model, which is to ensure non-divergent projection mortality rates in the long run. Okay, so after we obtain the forecast of mortality rates, then we are going to use these forecast measurements to launch the mortality life table, okay, to launch the mortality life table that take into account for mortality improvement of future trends. So this kind of mortality table is also called as the projected life table. Okay, so kejap ya. So we have the current mortality table that we have right now is called as the M9903, and the one that we are going to do right now is called as the projected life table. Okay, so this is what we are going to do now. Okay, so the projected life table, it is important for the insurance companies that requires longer term investment, such as life annuities, pension and lifetime sickness insurance. Majority of the insurance companies nowadays, they use the mortality table, this one, that is outdated, which covers from 1999 to 2030, in which the mortality improvement after 2030 onwards were not included. Okay, so to provide accurate pricing and reserving, accurate life expectancy should be calculated. And hence, mortality improvement of future trends should be included while doing the mortality table, especially when Malaysia is expected to be an aging nation in a decade, which is we have, okay, a decade more to reach 2030. And this is why mortality modeling is significant, which is to make projection on the mortality table. Okay, and here is the suggested future works to make projected mortality model more accurate. It is important for us to incorporate recent informations or events that would bring changes to the mortality rates, such as the COVID-19 cases. Okay, diseases, lifestyle, etc. So because if we could incorporate more variables in the modeling, we could actually do some policy changes. Okay, however, because our mortality table, it does not include variables such as in terms of COVID-19 cases, therefore we cannot do the policy changes. We can only do the mortality table. Okay, therefore future research should consider new factors that could include all this kind of information into their modeling. Okay, another limitation of my study is that the model has redundant errors. So if you have any ideas how to develop the models into unified estimation other than state space model, you could actually contact me in this email, sitirohani@utm.my, so that we could do some collaboration in the future. Okay, I think that's all from me. Thank you.
Thank you, Dr. Sitirohani, for your informative and very interesting presentation. I believe that all the presentation today is very interesting and very relevant with the current situation, and we would like to know more. Okay, all the presenters, maybe we need to allocate more time for you, and we can have a special session for all of you, each and every one of you. So now, let us look at the chat box. Do you have any question? Since we are running out of time, okay, let's take one question here. It's from Chibuike. Yeah, I think this is actually for Prof. Hafsa. Chibuike would like to know how were the data that you showed just now contaminated. He would like to know more how to do that, the contaminated data. Prof. Hafsa.
Okay, all right. So first I generate the data, each of the independent variable, uniform 01 if I'm not mistaken, Then we replace I think the first, well, it depends on how many percentage of contamination that you want to have, If you want 10%, then you replace the first observation, the first 10% observation with values which is high, with high values, to make it a high leverage point. Okay.
All right. Okay, I hope that would answer the question from Chibuiki, yeah? Just another question for Dr. Siti Rohani while waiting for Dr. Siti Suzlin. Okay, during this pandemic, we know that the government has tried to provide or help us with a lot of moratorium, for example, where the changes of the time when people would do their pay for their loan, isn't it? So how do you think that your mortality model will help the bankers in handling that kind of problem? Or maybe you should propose to them that they should use your mortality model.
I think in this COVID-19 crisis, the news that just recently proposed by the government, if you have heard it, is on the increment of the retirement years, right? The government want to increase the retirement years from 60 to 65. And also, they also propose about the EPF withdrawal, right?
Yeah.
So I think the importance of the mortality modeling is that we could actually help the government to actually suggest what is the correct retirement age. Instead of 65, is it true 65 is the correct retirement age for the citizen nowadays, or it should be more than that? So in order to have that the accurate estimate of the retirement years, we need to do proper mortality modeling in order to forecast accurate life expectancy. Because the retirement years is related with the life expectancy, because government afraid that the retired people, they won't have enough retirement income. That's why the retirement years is increasing. That's what happened in Singapore, for example.
Okay.
Yes, and other countries as well.
All right. Thank you, Dr. Siti Rohani.
Okay.
And I think, yeah, we have come to our end over here, and let us thank all our speakers today, Dr. Siti Rohani, Prof. Habsha, and also Dr. Siti Suzlin Supadi. Thank you so much for your interesting talk, and of course, we would like to know more from your research later in the future. Over to you now, our host.
So before we go, I'm just going to say that we have two upcoming events in 2021, in August 2021. It's going to be two events in one. This event is going to be organized by MyHim Solutions Private Limited Company, which is a spin-off from Center for Industrial and Applied Mathematics. So there'll be two conferences in August. The first one is the International Seminar on Mathematics in Industry 2021. That is the website, siam.utm.my/ISME 2021. That's the first conference. And another conference is ISM International Statistics Conference. So this conference is, the owner of this conference is Institut Statistics Malaysia, but UTM will be hosting this event for this year. It's also going to be on the 17th to 19th of August. So it's going to be co-located together, one event for statistics specifically, and the other event for mathematics and other discipline as well. And it's focused on mathematics in industry. So I welcome everyone to join this event, and the website is on, but the registration will be open sometime in January. Okay? Right.